Okay, test. I should be live. Good evening, everyone. Welcome back to the stream. One quick thing I'll mention right now. I have a fan running because there's a heat warning here. I've tried. It seems that like the noise cancellation removes it. If it's actually audible and bothering you, let me know. I'll remove it. Otherwise, no big news to start with because last stream was Tuesday. We made a lot of progress, but nothing much has changed. On Tuesday, we fixed a few bugs in the evaluation of the expression of constants. There was a divide by zero that was left there. Basically, we would try to reduce to calculate constant values at compile time, and division by zero, we didn't have a check for it, so we would happily divide by zero and crash at compile time. At fixed, there was a bug in the comparison of structs that has been fixed as well, and we made some progress on functions. This evening, I'm hoping to go back to function expressions and make more progress there. But again, otherwise, I think no big news. So yeah, let's get started. I'll get back here. And yeah, so at the end of last time, we've done this binary int expression thing, this binary Boolean expression thing, and we used them to implement subtraction, multiplication, exponentiation, division, modulo, and or the Boolean expressions. We are missing a few more of the operators. We are missing, if I remember correctly, I did not remove the comments for the ones we have implemented. I'm going to do that now. We're missing addition, because addition is a tiny bit different. And we're missing the comparison operators. And then after that, we'll have to do the assignment operators that we haven't done yet. But after that, we should be done. Since for now, since I haven't actually worked on implementing vectors and dynamically sized types, we don't have vectors at the moment. So all of the range expressions are something we don't support yet. But otherwise, after all of this, we should be done for function expressions, and we can move to function statements, and we'll finally get to a point where we are done with the analysis of parsed code. So let's start with addition. Because addition, I'm not going to be able to use the same binary int expression I've been using for other binary int expressions, because again, the plus operator will at some point be also allowed for string concatenation. So I'll need to do something a bit more complicated than this, which means I can probably copy this, and in the case of an addition expression, do something a bit similar, but include the difference for strings at a later point. Is it addition exp? It is, yes. So what do we do? Actually, I'm gonna not in vertical. It's a different thing. We go recursively on the expression on the left-hand side. We go recursively on the expression on the right-hand side. There's no need to short-circuit here or anything because this is purely the analysis, so name checking, type checking. Both of them need to happen anyway. And what we're doing here in the case of an int binary operator is to try to see, do we have constant time, like compile time values, basically? Do we know at compile time what the values are? If yes, we can do constant unfolding. We can replace 3 plus 4 at compile time with 7. And otherwise, then we need to do some type checking, check that both sides are of a type that is int or compatible with int, and then keep this expression for later, because at this stage we're not able to perform the computation. It will be a runtime computation. So here we need to do basically the same thing. However, we will need to also supports string expression, string expression. And here, this would be pure of an int expression, which is just, oops, L plus R. And if it's a string expression on both sides, and that's a compile time known string, we can do this basically. However, here is where it gets complicated. Because here what we're doing is like, oh, the left-hand side must be int, the right-hand side must be int. If either of those is not true, we have an error. That's easy. However, here we need to check that both of them are int or both of them are string, basically. And I guess the easiest way to do so is I'm trying to think about also how I want to do my error reporting. Because I was going to say the easiest thing to do is, well, the type on the left matches int and the type of the right matches int. But if, or otherwise, both of them match string. But in the general case, otherwise, where neither of them, they don't both match int or both match string, what's the error message? What's the type that I expect and the type that I got? Do I need to do I might need to check. I might need to check basically which of them is correct so that I can then do an error message based on. Give me 1 second. I might have to do the full tree of checks to be able to make an error message that's correct. As in, if the right-hand side is int and the other is neither int nor string, then it's the left-hand side that is wrong, and that's the one I want to include in the error, basically. So I guess I can do a first switch on the left-hand side type, and use that for my error message. If it is int, I am expecting int on the other side. If it is string, I'm expecting string on the other side. If it's neither, it's an error regardless of what the right-hand side is. This might be the easiest way to proceed about this. So if left-hand side type matches int type, we're going to do something. Otherwise, if the left-hand side type matches string type, do I have a string type? I don't have string type yet. Because I haven't worked on string yet at all. Do I want to add it now so I have access to it and I can start making my code correct even though there's no way to express strings at this point? Yeah, probably. The only thing is I don't know. I might want string to not be a built-in type, but something in the prelude, therefore something included everywhere that happens to be a type alias for vector of character or something. So maybe I will not want to do it that way, so maybe I can't do that yet. So maybe for now, what did I do for constants actually? If I go back to here, addition expression. I see. Since I always know the value at compile time, I check that the type is one of the correct ones on both sides. Then I check that they both match. and then I do a case on the actual literal expression. That doesn't need string handling just yet at this point. I think I'm going to do something similar where adding string support will be easy, even though for now we don't have a string type. Otherwise, and this will be basically the third case, even though for now it's just the second one, we will deal with like neither of those things are correct. So this will be a fatal error of error wrong type. I expect an int type or a string type that doesn't exist yet. And what I got was this type here. In the case where I have an int, however, I will need to check that the right-hand side matches int. I don't have a string expression either, I think. Those, yeah. So I can't do that yet. I'll need to comment it out. But the logic is sound. Okay. And here, since we're in the case where it's an int on the left-hand side, the right-hand side must be an int. And that's going to be a fatal error at this point. And the result will be something along those lines. A typed expression of type int, which will be an addition expression. That is not correct. If LHS is a typed expression, then I must extract its type for the comparison. Yes, it is the expression type of the left-hand side. That is what I want to try here. Okay. So that should be addition. Which I guess I can try on its own. Just to make sure I didn't break anything. Compiling the parser is so slow. There we go. Oh, that reminds me that I want to make a change to the parser and that I might do this evening. It's going to be a quick change. You're unhappy about this. Because that's not the name of the constructor. The constructor is just expr. Okay. And here, yes, I'm saying this is the wrong type, but as a result, I must provide a type, and this is not a type. This is a typed expression with the type and the actual resolved expression in it. I need to extract the expression type of this thing. To be consistent, I've used $above. I'm going to use $here as well. Okay. That should be it, hopefully. Perfect. Which means, if I go back here, if I try a very basic y plus 1 here, this should still compile. If it compiled before, I'm passing a reference to x here. This is a function that takes a reference. Okay, that should be fine. Let me put this where you can see it. There we go. That compiles just fine. And the function is called foo. And this function foo here, we do get an addition expression. Okay, so that worked. And if I had tried to do a y plus a character, I would get... oh. What error did I get? I got... No, I did get an error. Perfect. Wrong type, expecting int, got character. Perfect. So that seems to be working, which is good. But now let's quickly do... Actually, I'm just going to commit this first because I'm going to then change something that's unrelated. A thing I want to change is there's an error in the parser given how the grammar of the language was defined. I did do something off stream, but not code, purely changing the README and some of the language definition and grammar to update with some of the changes we've made. And one thing I've noticed that had been bothering me when I've been writing code here in this test file is there is an error in the way I handle type arguments. So let's go fix this quickly, which is that when I'm looking at a path expression, where are you, path expression? There you are. If they are generic arguments, they are after a double colon, which is the same way Rust does, where you have this fish operator if you try to pass type arguments to a function or something. However, within the brackets of something, you should not need that. And at the moment, it's required. And I think it is just a matter of, here in a type expression, not having them before the generic arguments, because that should not be ambiguous in the context of a type expression. Finding an open angle bracket will never be understood as being possibly a comparison, because in the context of a type expression, that's not ambiguous. So I think this is correct. Oop. So let me check that. What was the syntax for this again? Happy something? Do I have happy in my history for this project? I should. I don't seem to. I don't. That's annoying. What did I want? I think it's info that I want. And I want to run this on it requires what's wrong? Oh, yes. Okay. Yes, in this case, this becomes $2. Aha, now there's a shift reduce conflict, which I think we had resolved all of them. So that's a bit of an issue. I really want at some point to just rewrite all of the parser with megaparsec and not bother with happy, but that's a project for later. So state 118 contains one shift reduce conflict. Okay. Okay. So if we find an open thing, either we shift and enter 129 or we reduce using rule 114. What is rule 114? Wait, this doesn't mention... None of this mentions a type. Oh, that's because we have a type expression here. So it would be possible to have an angle bracket that is a comparison operator if we have a cast before a comparison operator, because that is a type expression. But I think that's because cast is an error. It's not a type expression, it should be a path expression. Because it is a type that appears in the context of an expression. So I think that if I change cast expression to be a path expression here, then I think the problem goes away. And now we are fixed. Okay. So that should be enough as a change. How big of a change is that? Oh, interesting. It was generated as part of a... Huh. So we fixed the path expression for the cast, and we remove this for the double column. Okay. Now, I suppose the big test will be first, let's compile this, and two, let's test it with our test file. So we don't have, we do have some, this might, will it break our existing golden tests? It might actually, we'll see. Couldn't match, okay. That is 103, that must have been... That must have been the path expression, or for a cast actually. Because this is now a path expression which returns a location and path info passed, while a type expression was only a path info passed. So that means that in the context of a cast expression, I need to extract the second element of this. Okay. Okay, that compiles, but some of the tests actually fail. The text init empty input. Interesting. Interesting. So that means I have some tests that have been broken by this change. Let's go have a look. Arbitrary. 45. Interesting. So that means I need to change this to be... Because I had this thing of like, oh, I'm trying to reduce a string which is of size 1, then I just give the empty string. Otherwise, I take all but the first element, all but the last element. The problem is, if it was empty, then it would not be equal to 1, and I would try that. So I need to change that. That was a bug in my test, to be clear. But it should still show some bug. Hopefully, there we go. Parser error operator less than expecting identifier. And that's because I probably have this round trip test is a test in which I generate an arbitrary AST, I print it, and I pass it. So I've made changes to my parser. If I have not made the corresponding changes to my pretty printer, the code will not do a round trip successfully. So I think that's what's happening. I need to go change that. So I think the problem is I am using the same type for a random path expression and for a type within it, which means types will continue using the colon, which is not, here we go, for a path info past, I will continue using this for the arguments, even though those are not necessarily required. And I think what that means is I should not have an instance for this. I should not have an instance for a path info. And I should instead have a pretty path expression and a pretty type expression. And they're going to be basically the same, except for that small difference. The type of which I'm going to leave as underscore for now. The compiler will tell me what the type it infers is, which is going to be from path info past to something else. So in the case of a path expression, this is that. That hasn't changed. And in the case of a type expression, it has changed because those two columns are no longer required. In both cases, this assumes that I have done this. There we go. So now interesting. I have this pretty params function that is basically the same thing that I'm doing here. So maybe instead I could deduplicate that and do pretty params. And therefore, I don't even have to do this case because it's done for me here. But the difference is I need to be able to specify whether the column should be included. So I guess pretty params needs to know what the opening thing is, which will be here. Okay. And that means here for a type expression, we can remove this case here. This is just pretty params. Using here just this. And in this case here, it is pretty params with the column. Shouldn't this hcat include? I don't remember how this pretty fire thing works. That was too long ago. It's probably this one. Yes, that's the one. Perfect. And I want to check what hdoc does. If I go to the top level, hcat. Okay, without any spacing, which is already what I'm doing, I think. So yeah, I guess I could, rather than doing all of this, I could probably do that, do this intersperse thing, and do plus plus. But the problem is I will not always get a value there. So I guess it's easier to do it this way. Okay. Okay. So now I can try to compile this and find all of the places where the instance is required and missing. Aha, pretty params here are missing. This is for a type alias, so that's just with this. This is for a declaration, so it's only just this as well, which it will be for me for most cases. Declaration, this is this as well. So what did you find as a type here? Let's see. Okay, that looks good to me. Except I know that this is a parsed one. Okay. The only thing is, I think something that is wrong here is that I'm making the assumption that the things within can be pretty printed, but I don't think that's true. Because if they are types themselves, then I need to use the pretty type expression. Therefore, that doesn't work. So I will need to give... I will need this function will need, rather than this pretty p constraint, will need a function that given some p gives me a doc an, which will be pretty type expression in some cases and pretty in some others. Okay. So this now requires... This is for the declaration, so where we have only identifiers that do have a pretty instance. So we can do that. And likewise here. Likewise here. Huh. I should have found... Oh, because I have a few calls to pretty here and there, like this one, which will not work. So this needs to be a pretty path expression. Likewise, this is a path expression here. And in those, I need to give as an argument always pretty type. There we go, and that should be all, hopefully. Okay. With actual type text, interesting. What did I change and why is this wrong? Because this instance used to return something that was the same type, an annotated document thing, and it was returning this enclosed sep thing as a map of... So what has changed? I can also, I think, rewrite this as being params null params equals memempty. And otherwise equals this. But let's have a look then at what enclose sep here is. Takes left delimiter, right delimiter. Oh, is the problem maybe that, yeah. Separator and then okay. I might have been reading the error wrong. I think the problem is that I've said that this must be a text, well, in fact, it needs to be a document as well that happens to have a from string instance. Okay. So now this is a case where... So this is in the context where it's a type, right? If I check my parser, in a type declaration, IS declaration here, that's a type expression, yeah. So that's a pretty type expression. That is in a struct. Yes, so there's going to be a pretty type as well. Type. Pretty type expression. I forgot to write the expression part on the other one. Expression. Let's see what I'm missing. Here. This is in the context of the return value of a function that is indeed a type expression. This is a type expression. A call expression, however, is a path expression. And is that all? Because a struct expression will also be a path expression here. I think it should be, at least. How is it represented here? Struct is a path info, yeah. And when we pass it, we must be passing... We pass a path expression, yeah. Okay. A reference is a path. And now, hopefully, the test should pass. At least the quick check tests should pass. The golden tests might not. Okay, no, they all pass. Perfect. That means that our very basic round trip tests, our very basic test does not contain type arguments, I suppose. If I look at integration test, it does, but only in places where nothing has changed. Okay. But at least the tests pass. However, now, if I go back to this, there are some tests in this that will no longer pass. Some of those, for instance, will no longer pass. This would no longer work. So if I copy this in the not commented part, this is a struct S3 with a T parameter. And now this is... Oh, no, actually, this should be... Aha. Within... So this S3 being in an expression because I am calling the name of this S3 to construct a struct, it must be using the fish operator. However, within it, that is no longer required. Same here. Oh, I need the S2 to be in scope, which is just this nonsense. And now this should pass, I think. Nope. Error, struct unknown field. Interesting. Oh, I have an error wrong type. Expecting in... Oh, that's this one. Okay. I have an error struct unknown field in S2. Of y is not known in S2. Yeah, that's true. I must have copied the wrong definition of S2. Or there might have been more than one. Not impossible, given the nonsense that this file has become. It seems to be expecting a y of type u. And now this compiles. Okay, perfect. So that's a small change, but now the grammar is first consistent with what we wanted in the first place, two consistent with Rust, at least for that part. So that's a small change, but that's better. So that means we have changed a lot of things in the pretty printing. Not a lot in the parser. Okay. And now with that done, I can go back to what I wanted to do this evening in the first place, which is to go back to functions. So we've done addition, that was missing, partially because we don't have strings yet, but that's still better than nothing. And now we can do some of the missing things. So we're missing comparison expressions. Oh yes, those are complicated. A thing we did on Tuesday was to fix comparison expression for structs in the context of constants when we know all the fields at compile time, because the comparison of structs must be done in order of the field declaration, with the first field being the most significant one. Which means if I'm saying those two structs of the same time, A is greater than B, then if the first field is not, then the answer is no. If it's equal, I must go to the next field to then compare. The first field is the most significant. But the order in which I have the expression, because again, in the case of constants, I know the expression at compile time, the fields might have been given in any order, and I cannot reorder them because if the first one errors, it should error before the second one is computed. So I had to do this complicated thing where I go fetch, after having computed all of them, I go fetch them in proper order to do the zip, like to compare them pairwise correctly, which was quite a lot of work, which I think I'm going to copy from, I'm going to copy from here. What's the difference between this comparison expression and compare expect? Ah, I see. Yes. Okay, so I'm gonna copy all three here: comparison expression, compare expect, compare expressions. And then I'm gonna have to adapt them to also handle the dynamic case that I don't handle yet. Which will be, if I use the same logic that I have used for those other functions, will be, okay, I can still do constant unfolding at compile time, but if I can't do that because not all of the values are known at compile time, then I must do type checking of both sides of the operator, make sure that the types match, and yeah, I guess the do I actually translate that at this point into a series of Boolean AND? Like, do I translate the comparison expression of structs if I don't have the values at compile time? Maybe not. I think it's only worth doing if I have two struct expressions that I know at compile time, even if they're fields I don't know at compile time. Then I think it's worth destructuring. So the destructuring case is only done in the constant case, kinda. As a form of constant unfolding. In the dynamic case, I think I don't. Okay. Okay. So this would be in this function here, where I have checked that the two types are the same and therefore they can be compared. And in the context of a constant, I am therefore assuming that I know what the type of the value is at compile time because it's a constant. I think here in this case, that is just the generic case where I know that they are of the right type, but I don't know what the values are because they are not known at compile time at all. I think in this case, I need to return excuse me. I need a constructor, which is the same thing I've been doing here. So I'm going to need this to be a type expression, I think. No, I don't need that, actually. No, yeah, we'll need that to be a typed expression, I think. Because either I can inline it and that's done in this function, or I cannot. Yeah, so I think here, instead of being this, but I will need... God, this was tricky in the case of a constant already. Let me think. I think I'm gonna progress step by step. The first step is I'm gonna ignore the default case for now. I'm gonna say this thing gives me a analysis M typed expression. Actually, at this point, do I need to be in the analysis monad? Do I need to do any lookup? Yes, I do. Oh, sorry, not this one. This one. This one I need to be in the analysis monad, but I can give, I think, a typed expression directly. Which means I'll need to do something here, which will be, I guess, an int expression. Yes. I'll need to do something smart for this case, which is going to be the complicated one. Then I'm going to keep for last. Wait, that's not correct. All of those are bool expressions. There you go. And I'll probably need from... Yes, I need a from maybe... Oh, wait, no. God, this is tricky. Okay, I'll need to think. So let's do things step by step. This is the case where I don't know the shape of the values at compile time. I just know that they happen to have the right type. That means that I know that the result of this is going to be a Boolean expression of... Oh, but Boolean expression is something they expect. That's not true. So it's going to be a typed expression of type Boolean type and of value, whatever that constructor is, with LHS field RHS field, because those cannot be computed at compile time. Except they're not called that. They're called E1, E2. Okay, so that part should be correct. What I need to fix now is this other case. I guess in this other case, I have the problem of... In the constant case, I written a maybe because I need to check... Here, I will not necessarily be able to compute all of the values at compile time. I might not have all of them. What does that mean? What am I trying to do? So let's, in this case, in the case of a struct, I need to do the same thing I'm doing here, which is to go in the order of the fields. But I need to generate basically for each of them. For each of them, I need to generate a for each of them, I need to check. I need to generate something extremely complicated. I need to generate an if of some kind. Like if those are equal, then continue. Otherwise, which will be what I will need to generate in the end. But do I want to leave this for code generation and not perform any inlining at compile time? Hmm. Can I do it with only one expression and therefore not having to insert statements? I think so, because for a field, that's complex. Let me think about it for a second, because I am not sure what the best approach here is. The question basically is, I have two structs whose shape is known at compile time. I have two struct expressions, but the field values might not be known at compile time. Is there a way for me to basically transform A is less than B into one expression that instead involves the values of the field to do the unfolding, basically? And the answer is yes, but the question is how. Let's write some examples. That always helps understanding what we're trying to do. So what I'm saying is I have, say, an S1x is foo and y is bar, or y is 1, less than some S1 that I also know at this point where x is bar and y is 0. In this case, the shape of the struct is known at compile time, so we can do smart things. Let's even say that there's a z here that is this, and there's a z here which happens to be the same. Because since we know the shape of those things at compile time, we can replace this not with call expressions. Although I guess we could do that in the case of the we could do that in the generic case as well, I suppose. Because this is basically this is this is foo is less than... I thought I had managed to... Yeah, it's something along those lines. It will be foo is less than bar, or, which should be enough on its own, because this is most significant to the least significant. So if the first field is less than the second, I don't need to compare the others, is the thing. Because if I go back to the Rust playground I had last time, if I have this X and Y thing, if I compare foo y6 x4 oops to foo y5 x5, they are compared in the order of the fields, and the first field is most significant. So x4 x5, this one is indeed less, even if this one has a second field that is greater. But we still need to exclude the worst case, which means this becomes foo less than bar, therefore it's true, or foo equals bar, and then it does the recursion. And then here it becomes recursively which is true for both. This is true for less or equal. No, for less. For less. No, wait. Because then it becomes one. Well, in this case, we know the values. But if we didn't know the values, we would still need to be able to say that at the end of all of this, the tail case is false if we want strictly less. The thing I don't like about this is that if we're trying to inline it, the fact that we have to translate it into this kind of thing mean we are actually making the call to the expression of the thing twice. We don't cache it. So I think instead, I am not going to do this. It's a shame because it feels like there are optimizations we could do at this stage. Because I guess I could rewrite it as like, okay, let's give a name to this thing. But if I give it a name and it happens to be S, and this one happens to be S1, this one happens to be S2 or whatever, I can rewrite this as being S1 of X less than S2 of X, or they are equal, and we continue the recursion. The problem is that now I need to introduce names for those things that I don't have at this stage. So I'm doing a much bigger AST rewrite because I'm not just rewriting the expression, I'm rewriting statements to introduce let bindings for those things that are being compared at compile time. I think what I could do instead is I still think there's value in doing unfolding at compile time. But what I could do is I try to resolve it at compile time, and if it cannot be resolved at compile time because one of the things is not a value known at compile time, then I do not resolve any of it at compile time at all. And maybe during the code generation phase, I can try to do something smarter, or during the optimization phase later on. I think that's the best solution. Yeah, I think that's the easiest. So we only do this if all of the fields are known at compile time. Therefore, all of the values are known at compile time. We never call the same underlying expression more than once. We don't have to generate this complicated thing. We can resolve the value at compile time. And if at any point in the resolution at compile time, we find something that cannot be computed at compile time, we do not try to inline anything, and we'll try again to be smart at code generation time when we are actually generating the bytecode. I think that's the best solution. Okay. So that means we need to rewrite. I think this is still fine. This might be missing a parameter, which will be this one, which we have for other functions here, which is, since this was written with only the constant case in mind, where we have, thank you. This was written with the constant case in mind, where we know all the values. Here we also need to know what constructor for when we have a runtime case, so we need to add that. And I think what that means is, as a result, this compare expression thing needs to be able to short circuit. It needs to be able to basically bail out and say, well, we can't do that, and therefore just not return anything. And I think the easiest solution is going to be to stack another maybe t on top of the thing. So this would be a maybe t there. So we make another maybe on top of the thing to allow us to short circuit fairly easily. And that means that we try to resolve the expression at compile time, but that gives us a maybe t value. We run the maybe t that gives us a maybe value in the end. And when that happens to be nothing, then we return. That means we could not resolve the value at compile time, which is fine. Oh, this is even worse. This is even worse. This gives us a maybe of a Boolean, because we have the default case to take into account. So we run maybe the compare expression that gives us a first maybe, a top level maybe that tells us whether we manage to compute the value at compile time or not. That contains, if it does not contain nothing, a second maybe, which is, could we resolve the comparison with what we had, or do we need to resort to the default case, basically? Okay. I think here, rather than trying to be smart with like some on nothing or something like this, I am going to be very explicit. If it's nothing, we could not compute the value at compile time, return a typed expression of type Boolean, which happens to just be this constructor between two values e1, e2, and nothing has changed. Otherwise, we have a maybe Boolean, and what we have, I'm doing a pure in both cases. That means I don't need to chain in my monad. I can do an fmap instead. And in this case, what we have is a constant time Boolean expression whose value is, from maybe default case, this value. Okay, and now compare expressions doesn't need the C constructor at all, and is basically almost the same as the one we had before, the difference being that if we encounter something that we cannot compute at compile time, rather than being an internal compiler error like it was for a constant, that's perfectly fine, and we must just short circuit, basically. Okay. Okay. So that means here, in this case where we don't find two constant time values that we can compare, we short circuit with M0, which means this top level maybe of the maybe T transformer will return false, and we will be in this case where we say, well, that's a runtime expression that will be evaluated at runtime. Otherwise, when we find things that are the same, then we can do the same thing that we were already doing. Which is that we apply this operator on the two values. It gives us a maybe Boolean. And that's all we need. Okay. And in the case of a struct, we must obtain the definition of the struct. That remains an internal compiler error if we don't find the type of the struct, because we should always be able to get the struct type. Not getting it here means... Oh, actually, maybe that is valid in this case? Yeah, I think it is, actually. It was not valid in the context of a constant, because the only time we can try to retrieve a struct and we didn't get an error trying to do so, but we got nothing, means that we have found the type in the scope, but there's no structure info associated with it. The only case where this happens is if the type of the struct is a template type parameter, is a type parameter of the function, and therefore we don't know yet at this stage what type it is. Which, for a constant where there is no type parameters, cannot be true, but for a function is perfectly possible. Which means, if that's the case, it means this comparison is happening between two structs whose type is... Wait. Yes, whose type is a type parameter of the function, which means I know in which order the fields were given in the constructor, but I don't know what the declaration order of the fields are, because I don't know what the exact definition of the type is, because it is a type parameter. Therefore, this is not an internal compiler error. This is a case where we cannot decide at compile time. Now, if we are here, it means we did find the struct info, so we are in a struct that is known at compile time, with two struct expressions known at compile time. So we can do this thing of trying to find the fields in each of them. This error should never happen because the struct expression has already been validated. Therefore, the fields must be valid, but may as well still have it here. And we recursively compare the expression, which either gives me the maybe Boolean value if we can do the comparison at compile time, or it gives me a top level false, like nothing, if we cannot, because any of this is runtime only, because it was not a compile time known value, or it was not a compile time known structure. Okay, so that should be fine now. And I can keep this exactly the same, to the point that I wonder if I should deduplicate it between the two things, but maybe not. Okay. And that means I can go back here and copy this basically identical for functions. There we go. I'm tempted to actually put them separately just for vertical alignment and readability. So this is equality, difference, greater, lesser. Okay. So we can try this now. If this compiles, of course, we can try to see if compile time values do get in line properly, if constant unfolding happens, and if at any point there is a value we can't know at compile time, it should therefore bail out and just give us a comparison expression that hasn't been inlined, letting us be smart at the code generation phase, basically. Okay. Let's try. Okay, it's not called go. I have the same error everywhere. This is called analyze function expression. There we go. Hello, I am continuing what I was doing last time, which is more function analysis. I just finished writing something for the comparison of values, the analysis of the comparison of values in the expression in functions. It's dark. I forgot some lights today. And I am trying to make them compile so I can then test that. I'm trying basically to do constant unfolding for comparison of structs, but if there are two fields that cannot be compared at compile time, rather than trying to unfold the thing, I just did like move everything to the runtime, and I will try to be smart and do short circuiting during the code generation actually, and not at this phase. Okay, so I am missing. Why does? Yes, of course. Comparison expression takes another argument than the one I've given here, which is the constructor to use. Shall we not be able to resolve the thing at compile time, which is the same thing that we were doing here, which means it is this constructor. This is going to be big. That's fine. Oh, it just fits, barely. Okay. Oh, yes, of course. Here, E1, E2 are not resolved. So in the default case where I cannot do constant unfolding and I need to just return the same comparison thing, but just with the values resolved, I need to give this actual thing. I'm going to name them left-hand side, right-hand side. And I will need to add parentheses here. There we go. What else is wrong? Ah, yes. This gives me something in the analysis monad, and I am, for the scope of this function, not in the analysis monad. I am in the maybe t analysis monad. I guess I could make a lot of those functions generic over the monad in which they operate. But since most of it will always be in the same, I could also just do a lift of this. And this is going to be the same thing. This is going to be a lift, fatal. I guess I could No, I can't actually lift the whole thing because this contains a recursive call to compare expressions, which is this thing, which is in this stack of maybe t on top of the analysis monad. Therefore, I need to lift the very specific things. There we go. However, I could be smarter, actually, and go to monad here and add a new instance, actually in diagnostic here, and add another instance for this. If a monad M has an instance of monad diagnostic, then maybe T of that monad should have also an instance of monad diagnostic. Will it overlap with this one? No, because this doesn't have an instance of monad diagnostic. Okay. I think it might, because the shape will be resolved. The shape will be resolved before the constraint is. So this instance will overlap with this one. But this one is temporary. Okay. For now, I'm not going to do that. I might do it later when I clean up this thing. So for now, let's go back to this. And let's keep the lift here rather than doing some magic with the instances. Okay. Okay. This is the same problem. And as a result, I think I can lift the whole thing rather than lifting it here. That is good. Perfect. What? Oh, I seem to have... There we go. Okay. And now we're back and all the tests pass. So that means that now we have added comparison expression in the context of function expressions. Okay, let's go test this. I'm going to continue having some very simple test code here. As long as I haven't finished the analysis, I can't really write tests for the whole thing, and therefore a bunch of things require more testing and doing a bunch of tests manually for now. Not great, but it will have to do. So, what I want to check is a few things. First, I want to check that if I have values that are known at compile time, they do get unfolded correctly. For instance, if I do 1 is less than 2 at compile time, I'm expecting this to be a return true, basically. And the function is baz. Baz is a function definition with a function info. The name of the function is baz. There's no type parameters. There's no argument. It returns a built-in type boolean. And the body of the function is a return statement that contains a typed expression of type built-in type boolean, the value of which is a literal true. So this worked. We did do the constant unfolding. We did inline the value properly. Now, if instead we have an int given as an argument, here we should return not a Boolean literal, but a typed expression of type Boolean, which will be a comparison expression between a int literal and a function argument, because we can't solve this at compile time. Okay. The return is no, that's okay. Return statement here is a type expression of type Boolean, and its value is a lesser expression, where on the left-hand side we have a typed expression of type int, which is an int literal expression, and on the right-hand side we have a typed expression of type int, which is a function argument x. So that works. We do the constant unfolding when the values are known at compile time. We don't otherwise. Now, the case I want to test, which I think is more interesting, is if I have this. I have a pair where x is 1 and y is 5, and I want to test that it is less than a pair in which y is 4, but x is 2, which is this thing where, since we are comparing in the order in which the fields are declared, actually, this is declared with x second. Let me do this instead. This means x1 is less than x2. That means that it will, since x is the most significant field, that means that this should return true. And we have all the values known at compile time. Therefore, we should be able to compute this at compile time. Boolean literal expression true. Perfect. Now, however, if the values of y are not known at compile time, even if we know that they are the same, because they are making a reference to the same function argument, that's a value that is not known at compile time. Therefore, my function that attempts to do... Oops, sorry, I hadn't seen your question. What does it do with... It should resolve everything that can be resolved at compile time. I'll try this right after. Here, however, we have values that are not known at compile time. So I think here, with the way our implementation is at the moment, it will not try to solve it at compile time, despite the fact that here, this could be solved at compile time. So I think we should improve on this. But I think at the moment, this will compile, but not do any inlining. And I think it didn't, given the size of the generated code. Well, not generated code, of the resulting AST, because the return statement contains indeed an expression, which is a typed expression of type Boolean, but it is a lesser expression. So we did not try to we didn't try to inline the thing, despite the fact that in this case we could. So we could try to be smarter than this. But at the very least, this works in the sense of, like, if all the fields are known, it computes the solution at compile time. Otherwise, if any of them is not, then it does not. Although in this case, it could is the thing, which means I might want to be smarter than this. Okay. So your question was, if there is a more complicated expression whose sub-expressions can be known at compile time, but not all of it can. And the answer is it will inline what can be inlined, but not all of it will be possibly. For instance, if I do 1 is less than 2 and 1 is less than x, I think this will be in line. This will be in line to, this is still an AND, but it will be true and this thing that cannot be evaluated at compile time. However, we could probably be smarter here as well and realize that like true and something is just the other one. So there's probably optimizations we can do here as well. Okay, so if we try this, expecting semicolon missing there we go. So here, this return expression has been, sorry, this is the return type, my bad. The return statement here contains a type expression of type Boolean, which is an AND expression. That is correct. That is this AND here. And the left-hand side is a Boolean literal true. Oops, this one. So we have inlined the fact that 1 is less than 2 to true, but we have not done anything here because we don't know what x is at compile time. So the second argument is a lesser expression that has not been evaluated at compile time. However, we could do something better, but it might mean that I cannot write generic functions the same way I'm doing, which is fine. Okay, so let's try to be smarter then. Let's try to be smarter. The problem. No, I appreciate it's the way this stream always works, right? It's always we stack more things on top of more things. And here it's basically we can do more optimizations. That's also good. Arguably, we could push them down to later, as in at a later stage when we have generated the AR and we do an optimization phase, we could do that kind of like, oh, we're doing 0 plus, that's the same thing, we can remove it. We could do those transformations on the AR rather than doing them at this point on the AST. But this kind of very simple expression transformation, where we are not changing the shape of the program at all, I think they make sense to do at this stage. The things we'll do on the IR will be more or less things like tail call optimization, for instance. So let's think about what we can do here. The problem here is like I have this binary Boolean expression for both and or, and the problem is that it's going to be difficult to write a generic version of this function that knows how to short circuit based on what the argument is, which means I might want to... Do I want to duplicate this function for AND and OR, basically, despite the fact that it's basically going to be the same? Or do I need to find a way to be smart so that the optimization can be done the same in like by just giving an argument, basically? I think no. I think the easiest way is to make it... So let's duplicate this. Actually, it's not duplicated. Let's just inline it for the two cases where it's used. Which are those ones? There we go. Okay. I'm going to move them out of the way because they're not nice and shiny like the others. There we go. So what do we do here? We do the same thing in both cases. We analyze the left-hand side and the right-hand side recursively. And here, if we know the value at compile time, then we resolve it. Except now we are going to inline this because we know what the thing is. And otherwise, if we don't know the value at compile time, then we check that both types are compatible with Boolean, which means it could be also just a type argument, but it is something that is potentially valid with a Boolean. And at the end here, this is a Boolean OR expression that we did not compute at compile time, in the same way that this is a Boolean AND expression that we did not compute at compile time. Where we can be smarter, however, is rather than saying we know both of them at compile time or any other case, we can try we know one of them at compile time. Okay, so what can we do here? Here we are in the case of AND. So if this is false, we know that the result is false no matter what. We don't have to so here we could just say false. In this case, which by definition is just the true case, then this is no longer this is no longer an AND expression. This is purely a typed expression where, of type Boolean, of course, where the value will be the right-hand side. So true and x is just x, basically. Okay. Can we do something in the other way around? If we have x and true, that's just x. If we have x and false, that's always false. We don't need to evaluate x to know that. The only problem I have with short circuit, with not evaluating x in the case of x and false, is that we are removing side effects potentially. Because usually in imperative languages, the left, like it short circuits from left to right. What does Rust do in this case? Let's have a look. I should really turn on some lights. It's very dark in here. Let me just see what Rust does in this case. So let's imagine. So I have this error. I have those error functions. I make a new one. Is it big enough, actually, this Rust thing? Or do you want me to zoom it? Let's say I have this. Oh, up, there we go. Error3 function that gives me a Boolean. And it just panics. So it will never return anything to me. Okay, thank you. If I try to print... If I try to print false and error 3, I'm expecting error 3 to not happen. Because at compile time, the compiler will be able to realize, well, even if it doesn't do it at compile time, the left-hand side of this AND is false, therefore its value will be false. Lazy evaluation of Boolean operators, the right-hand side is not evaluated. So this should just print false and not panic. Never constructed, never used. It prints false. That's fine. What I'm curious about is this. If I do this and false, sure, we know that the result will be false because this is the AND with a false value known at compile time. The question is, does the short circuiting still happen and therefore remove the side effects of the left-hand side? And I'm not sure what the answer is. And the answer is no, it does not. This panicked. So despite the fact that we know for a fact that this will return false, we do not short circuit, and therefore we do evaluate the left-hand side, even if it means, like, we know this would return false, but we don't short circuit, basically. That is interesting. I think I don't want to change those semantics from Rust into my own language, because short circuiting being done on the value of the left-hand side is what most languages do. So that means what does that mean actually? Can I change this? Can I change this? Because in my control, I'm trying to think, is there a way for me to transform this expression so that the left-hand side is still evaluated so that side effects are performed, but I still add at compiler time the information that I know that this will always return false? Because if I have this information, I know that if this Boolean expression appears in if, for instance, then I know that the branch will never be taken, and I can use that in my control flow analysis, because I know that either the thing returns a panic or it returns false. It can never return true. Is there a way for me to annotate my resolved AST to convey both that the function should be called for side effects, but that I know ahead of time what Boolean value it will be, because it can always be false or a panic? Do I have a way to annotate things that way? And I think I don't. So I think I'm not gonna bother at this stage, and maybe I can do some optimizations when I do the control flow analysis. Maybe I can try to be smart at that point, but here I don't think I can. I would need to introduce some kind of new expression of like evaluate this but always return that I don't have the tools for at the moment. So I think for now I am not doing any short circuiting based on the right hand side. If the left hand side is known, I can. If the right hand side is known, I am not doing anything, I think. So let's do the same thing here. For the OR, it's going to be different, where if the left-hand side is true, then the whole thing is true. And if the left-hand side is false, then I just return the right-hand side, because false or something is just that something. But I do not do any optimization based on the right-hand side. Or at least not at this phase, in this phase. When I do the code generation or do the IIR optimizations, I might be able to identify, hey, this branch can never be taken and therefore can be pruned, but I don't think I have a way to signal this at this stage. Okay. That's a shame, but oh well. Okay. So that's short-circuiting done. Is there something else I wanted to do? I probably want to do the same thing with like the neutral value of some other operations. Like divided by 1 is always going to be the same value, and therefore it can be removed at compile time. The only problem with this is I think it means that here I have this binary int expression and so on that try to do the same thing for all of them. If I start trying to match on specific values to try to deal with some of the operations ahead of time, I think that means I have to inline all of them. I cannot rely on a helper like binary int expression anymore. I am going to have to do this manually for all of them. But that's probably worth it. So I should probably do it. Okay. Give me 1 sec. I am just going to turn on some lights because it is dark as hell in here. Be right back. Okay, that's better. So, we've done the simplification, the inlining, the short circuiting for booleans. I think we have no choice. I'm going to have to do the same thing. I'm going to have to inline all of those things to be able to do the same thing in all of them. That's a bit annoying, but that's fine. I guess I can start with plus, where in the case where I have an int expression of 0 and something, then the result is whatever the int expression on the right-hand side is, because 0 is the neutral element. Likewise, if I have something plus 0, I can at this point just say that's just the left-hand side because 0 is the neutral element. So I can do that for plus. I will be able to do that with like the empty string at some point when I support string concatenation. And now that means that for all of this nonsense, I am going to have to inline all of them. Okay. Let's move them here. Let's remove this function that's no longer needed. Let's remove this that's no longer needed. And let's copy this. Oops. Okay, so now this is this. And I'm going to copy this as a comment. I'm going to keep it so I can see what I was doing before. Okay. So let's do this one by one. In the case of subtraction, this is the same thing everywhere. We go recursively on the left-hand side and the right-hand side, and then we try to see if we can do something smart. In this case, it's going to be the exact same as this, which is that, well, not exactly the same. If we have minus 0, it's just the left-hand side. But if we have 0 minus something, this is not just the right-hand side. It's a int negation expression of the right-hand side. Okay. And I have to change a few things. F was the function to do, so this is basically L minus R. This does not need to be in a monad because this cannot fail, so this is just that. and the constructor in the case where we cannot compute the value at compile time or simplify it is subtraction expression. Okay. Multiplication. It's going to be the exact same thing, except we are going to copy this. But if it's a 1, oops, where did I go? There we go. Actually, for a 0 as well. Wait, does Rust do short-circuiting of the right-hand side of multiplication by 0? Let's try. Error 2, 0 times error 2. I know this is going to be 0, regardless of what error 2 is. Does this error? Or does this just print 0? Oh, fascinating. Okay, so anything that could perform side effects and it is not intuitive for it to short circuit, we don't short circuit. That means even though, again, we know that the result of this will be either panic or 0, we don't try it. We still, we know the result is going to be 0 if it doesn't panic. We don't replace it with 0. We don't remove the side effect. But yet, a control flow analysis would probably be able to say that if we have if 0 something, in a condition, that this will always be 0 and therefore be able to detect dead code. But the side effects need to be performed. So, for multiplication, we do not simply... Wait. Yes, even on the left-hand side. So for multiplication, we do not do 0 multiplication becoming... So yeah, it's just this multiplication by 1 that we can remove. But the side effects must be performed. So even if we could say, oh, you're multiplying by 0, that's a 0, we can't remove the side effects, therefore we don't. Okay? Oh, unless is it... Oh, wait. What if I compile with optimizations? Nope, it still panics. Okay. Even with optimizations turned on, Rust does not evaluate this oops to 0 because we know that this will always be 0. The side effects are preserved. Okay. So here for multiplication, we cannot use the knowledge that one of those two is 0 to replace everything. We have to keep the side effects if we want to be consistent, which I think we want to. Okay. Okay, so this goes away. Exponentiation. That's the same thing, right? It's just to the power of 1 or 1 to the power of... Wait, no. 1 to the power of I cannot replace because even though I know the result would be 1, I need to perform the side effect. However, in the case of something to the power of 1, then I can just replace it by whatever the value on the left is. I can replace it with whatever the value on the left is. Actually, I'm going to stack something else on the stack of things we're doing today. Give me 1 sec. I need to also finish doing this properly, which is here, this is multiplication. Here, the constructor is multiplication expression. There we go. For exponentiation, if the right-hand side is 1, oh, and this is no longer... This is now pure because we don't need the monad because this cannot fail. Okay. Here, however, this can fail. I need to check that I don't have negative values, because our language does not support floats. So, what happens in GHCI if I do 1 to the power of -2? I get an exception. I get negative exponent. Since I didn't check for that, that means that if in this language here, in a constant, I do 1 to the power of -2, I crash with negative exponent. So, we're gonna need to add more checks. Okay. So here, this is indeed in the monad, because I need to check that when are the exponent 0 is fine, right? Yeah, 0 is fine. That's just 0. That's just 1. When r is less than 0, then diagnostic, I think I have divide by 0. I can add a negative exponent. Fatal negative exponent. Error negative exponent. And otherwise, I can return pure of this. Okay. And can I do that? Would Rust do that? I don't think Rust actually has an exponentiation operator. I could, at compile time, say, hey, you're doing a negative exponent, that makes no sense. Rather than having it crash at runtime. If I know the value at compile time, I think that makes sense. So, that means that if I have some int expression here on the right that I know at compile time, even if I don't know both, I can do this. If r is less than 0, fatal error. If r is equal to 1, then pure typed expression in type left-hand side. There's no point in calculating something to the power of 1. However, side effects must be, like, the values still need to be computed, so I replace x to the power of 1 by x, basically. And otherwise, I have a value that is not negative, therefore valid, and not 1, therefore a computation needs to happen. And in this case, otherwise, we return a typed expression, which is an int, and in which the value is indeed an exponentiation expression of the left-hand side. And the right-hand side, nothing has changed, even though I know what the value is at this point. Okay. Okay, nothing here has changed, except here this is an exponentiation expression. There we go. Okay, so now I need to go do... I need to make the same check in constants. So here, for exponentiation expression, rather than using this pure of the exponentiation, I need to do safe exp, I suppose. which I can probably define. I'm gonna define with save div. It's fine. Save div is here, and save exp is going to be even simpler. It is a function which I can just uncurry at this point. Well, not uncurry. You know what I mean. When y is less than 0, fatal error, negative exponent. Otherwise, pure x to the power of y. Okay. Save exp. And now, when this compiles, we can try again to make sure that this doesn't crash at compile time. It just reports an error to the user. Okay. Okay. So that's better now. That's one more that's done. Division. Division, there's not a lot we can do, but we can do the same thing, which is, at the moment, we were doing this thing of like giving a function f that happens to be safe, because it was doing a safe division that was checking for division by 0. Instead, I think I'm gonna inline it here and do basically the same logic. So here, when the right-hand side is 0, then fatal error with error divide by 0. Otherwise, that is indeed left divided by right. And when I encounter something where the right-hand side is known at compile time, if it is 0, I can do an error division by 0. I guess in this case, since I'm not doing I can just actually match this. In the case of a division by 1 where the 1 is known at compile time, I can replace this with the left-hand side because there is no point in keeping a division by 1 that does nothing. And of course, if both were known, I would have already computed the value. And finally, if I don't know what it is, but I know it's neither 0 nor 1, then that's a regular case. Well, I guess I don't have to write this case. I can just let it fall through the default case here. It doesn't matter that, like if I don't need to duplicate this, basically. This is just checking the types and then outputting the same thing anyway. Okay. Which I guess I could do the same thing here. I could say, when that's 0, and other one, oops. And actually I can do that. I can do that. If the right-hand side is 0, divide by 0 regardless of what the left-hand side is. If the right-hand side is 1, return whatever the left-hand side is, and if it's a constant, that's just going to be that. It's going to be propagated properly. And if I have then constant values none at compile time, but I did not match any of those two cases, then I can do the division at compile time. And otherwise, then that means at least the right-hand side is not known at compile time. Well, at least one of those is not known at compile time, rather. And then we have to do type checking and returning this. Yeah, okay, that should be fine. Modulo should be basically the same thing. I'm going to actually just copy it directly. I think it's going to be the easiest way to go about this. Oops, that's a lot. Because if I try to get the modulo of the right-hand side being a known 0 at compile time divided by 0, modulo 1, however, will always be 0. Yeah, but things that always give me a known value are things that I will not remove at compile time because, again, side effects need to be performed. So a function, the result of a function foo multiplied by 0, I could replace by 0 because mathematically I know that it will be 0, but that would be short-circuiting the call to the function foo that might perform side effects, which means I cannot do it. I think it's the same thing here of like modulo 1 will always be 0, but if I were to replace the entire call with just 0, I would lose the fact that the left-hand side might perform side effects. And I guess it's the same thing with the left-hand side. 0 on the left-hand side will always be 0 in the modulo operation, but I cannot inline it necessarily because the right-hand side could be performing side effects, and there's no guarantee that those operators are lazy by default. I could make them lazy in my language, but that's usually not how languages like this perform. That's not how Rust is implemented, and our fake language is based on Rust as much as possible. So we are not doing smart things in the case of a modulo by 1 or something like this. The only thing we test is 0 to be able to say division by 0. And otherwise, if both are known at compile time, then we can compute the value at compile time. And otherwise, we have to move this to the runtime. Okay. Then we have our Boolean expressions that we have already inlined. I guess I could, it doesn't matter. Okay, so that should be all of those. Which means I should be able to try to compile this already and check a few things. And then we can go back to our comparison expressions not being smart enough in terms of optimizations. Okay. Let's try to compile this. Oh, I was a bit too aggressive here with my simplification. I forgot those 2 lines. Oh yeah, of course. In this case, I am trying to create a typed expression that wraps some expression, but this is already a typed expression. Oh, so I need to validate its type, actually. So I need to validate its type. Okay. Which I'm going to need to do everywhere. Oops. I was here. If the left-hand side does not match int type, error wrong type with the left-hand side, and pure the left-hand side. Okay. Because here, yes, this is the case of... Yes, I'm going to have to do this in every single place where I do simplification. That's the case here for subtraction. I need to check here that the right-hand side is the correct type before I return this. Here, likewise, I need to check that the left-hand side is correct before I return directly the left-hand side, because -0 is always the same value. Okay. Likewise for multiplication here. Oh, I need to make all of those do blocks, which I haven't done. Okay. I'm almost tempted, since in all of those cases, not enough of them, it's the left-hand side that is used for simplification. I could just evaluate the left-hand side and then... Or I guess, rather than doing it here, I could do a first phase of AST transformation before I do the analysis. Because after all, a lot of those things could be done purely at the AST level, rather than doing it when I'm doing the analysis. Maybe that would make a lot more sense. And therefore, I don't have to do those things at compile time. Well, at analysis time, if I have a simplification phase first. Because that would be a trivial thing of, I don't do type checking, I don't do name checking, I see 0 minus something, I replace that with minus something. Maybe it would be a lot better than this kind of short-circuiting I'm trying to do at the moment. I think it's better to do it as an AST transformation before the analysis phase. Because if I do it as a transformation before I do the type checking, I don't have to do the type checking in all of those branches, because all of the replacement happens first and then type checking occurs. Yeah, I think I'm going to remove all of this that we've done. Well, not all of it. I'm going to remove some of it, and I'm going to introduce a new phase, which is going to be the simplification phase. Does that mean that I'm going to have... Oh, that's going to be a big change. I am stacking more things onto the project. Let's go. Okay, so I am going to remove all of the cases of... I'm going to remove all of the cases of simplification. I am not going to compute all values ahead of time in the simplification phase. Like, I'm not going to do the 3 times 15, 15 times 15 is 45 during the simplification phase, because this still requires type checking. So I'm only going to do 0 minus a thing is minus that thing, or that thing minus 0 is that thing. Things that still require type checking, but can be just removing something, basically. Not computing something, removing something. So those optimizations on addition go away. Oh. I had some duplication there. Interesting. This subtraction thing goes away. This multiplication thing goes away. This exponentiation thing goes away. This division thing goes away. I can even remove some of the checks here, like negative exponent, because those will be caught by... Will those be caught by the simplification phase? No, they will not. They will not. I am only gonna remove things. I am not gonna perform any checks. So no, these need to stay. So in this case, I need to keep this when r equals 0. There we go. Okay. And I can do the same here. I can keep this. Because modulo, there's no simplification we can perform. Oh, I need to be careful. This is modulo. As a result, even those things here, which we're lacking the type checking, I'm going to remove. Likewise here. Okay, so does that mean actually that I can go back to Boolean expression being the way it was? Yes, I think I can go back to... I think I can remove all of those changes because we're back to exactly what we were. There is a case in which we know the values at compile time and we perform the operation, and there's the case where we don't. Okay, so that's a shame. But subtraction goes back to this, multiplication goes back to this. This will have to be changed to safe exp, but that's fine. So I go back to this, basically. What else do I change? I'm going to keep this comparison stuff because that is still new and that needs to be there. But basically everything else that is in there, I am going to discard. All this work discarded. And we're back to this. With now this being safe exp instead. Because we only perform the computation here when we have both of the values, because the simplification will have happened ahead of time to guarantee the type checking is fine without having to do type checking in every branch. Okay. So let's make sure that this compiles. It will still be wrong in terms of that the simplifications are no longer there. Well, not wrong, you know. The simplifications are no longer going to be there, but that's fine. I need to actually remove them in the context. Oh, no, in the context of a constant, the values are always there. So the simplifications are irrelevant because we are always going to be computing the values anyway. So that doesn't matter for this. I don't think I change anything here, in fact. I changed safe exp. Yeah, and I did the comparison expressions. Oh, actually, I think there's something I might have removed by mistake. The comparison expression should be there already. Yes, I think I removed them by mistake from this. Okay, let's fix that. Because if I go back to constants, I can copy this, go back to functions, and add them here. And here the difference is, after this compare expect thing, I need to give the constructors, which are those. Okay. So this should still compile. This should fix the problem of negative exponents crashing at compile time. But this removes all of the optimizations of simplification because we are going to introduce a simplification phase. Okay. Which means now, if I go back to this with this constant here, rather than crashing, our compiler should just give us an error saying, hey, negative exponent. Nope. Something else crashed. What did we... Oh, no. This is fine. This is not a error. This is indeed a regular compile error. We got an error negative exponent. Everything is back to being fine. Okay. So let's commit this. And then let's introduce a new phase. Okay. So now what I want to do is to break everything. Let's go. Let's go for a big change. What I want to do, and that's going to be a big change, is I want to add a simplified here, which basically states that our AST has three forms. It's been passed, it's been simplified, and then it's been resolved. The analysis, the thing we've been working on for months at this point, is the phase where we actually take the previous state and we resolve everything, which is name checking, type checking, all of that good stuff. We're going to introduce a new phase in between. To guarantee that the simplification has taken place, that means the input of the analysis is no longer going to be the passed version, it is going to be the simplified version. Which means we have to introduce a simplification phase. So we have to do a few things. First, the output, the AST will have the exact same shape after being simplified. So I can replace this passed with simplified. Because this is going to be purely about, this is going to be a non-error thing. This is going to be purely AST transformation of very simple things. So nothing else changes, okay? However, if I go to if I go to phases, stages, analysis, here the input to our analysis of a module should be this module thing, and this module thing should as well now be, unless I do, no, I think it's better to clearly do it ahead of time. I pass, I simplify, and then I give it to the analysis. I think if I make the analysis do, no. Okay, so this is now also parameterized by the AST phase. There we go. Which means the show instance cannot be the same anymore. It needs to be this. Okay. That doesn't change. That doesn't change. There we go. Okay. That means now that I can go back to the analysis, and the input to this is no longer a module, it is a module simplified. So we have passed, and I guarantee at this point that we have done the simplification phase because the input of the analysis phase will be a simplified module. That means I can go through all of the file in analysis, and I can do a replace of past to simplified. I don't know if I have anything past in this, actually. I don't. Instantiation, I don't have anything here. Do I have anything past in here? I do, actually. Okay. Okay, so that should be all of it. So now I have changed every single function in my analysis to take something that has been simplified in the first place. Okay. That means now that we're missing one big piece, which is the simplification phase. Let's add an entire new phase to our thing. It's fine. Simplify module is something that's going to take a module past, and it's going to return a module simplified. And that doesn't need to be in some kind of monad. This doesn't need to return some diagnostics. This is purely a AST simplification of things that can be simplified, guaranteed, like things that can be removed, basically, without type checking occurring or anything like this. So this is going to be a very simple phase, but nonetheless one where we don't have to perform all of the checks. We don't have to like do all of the branches during the analysis phase and add more type checking. So this might be where I end up using the plated instance of expressions. It's very likely that this is where I'm going to use the plated instance of expressions, because I think I have made plated. I have. Perfect. Because I think that there is no like the simplification phase cannot operate on anything but expressions, right? There is nothing at the type level I can simplify in a way that's guaranteed to not change the semantics of the program. I think I can't do renaming or anything like this. The only things I can do is like, hey, you're multiplying by one. That's useless. There is no point in doing that. So I think it's always gonna be on expressions. I'm almost tempted. I'm almost tempted, but I don't think I will need it anywhere else, and therefore that would be like complicated work that is not needed. I'm almost tempted to define a bunch of lenses to basically extract all expressions from a given type and then define those lenses on all type of my AST so that on any type of my AST, I can go give me the lens of all of the expressions because I'm doing purely an expression transformation. Except since I've introduced this simplified thing, that means I will probably not be able to use plated because I will need to also do a type transformation at the same time. This type transformation is not that important. It is only there to guarantee that the input to the analysis phase is something that has been simplified. It's kind of a phantom type at this point, but yeah. Okay. I think that means I have no choice. That means I have to rewrite, simplify on everything. Oh well. I am tempted, however, to try to see. I was going to say, can I write a generic. Can I write a generic. Like, make it a type class that is a thing is simplifiable if it provides simplify, and write a generic implementation that automatically do simplify on all the fields that happen to be. That is probably doable, but that's going to be a lot of work. Oh, actually, yep, this is simplified. I need to not forget my boot file. Okay, I only have one. This is going to be a lot of boilerplate is the only thing that bothers me a bit. I tend to prefer avoiding tons and tons of boilerplate. Because it's going to be the same thing of analyzing a definition and so on. It's just going to be so much smaller. Do I want to just make it a type class? Maybe. Maybe. Simplify module is just simplify. That's the interface that's being exported. Simplify module. And below that, there is a local type class, simplifiable. What's the spelling of that? This way. Where a type of the AST A, where there is a simplify function from A of past to a of simplified. And now is where this gets long. Let's take every single type in here. Let's do a keep lines data. Okay. Wait, that syntax is wrong. I have something wrong in my definition of module here. Yes. There we go. So import type expression do not require any of this. All of those, however, are good. Okay. So what I can do is why aren't you happy about this? Oh, because I did not do a replace regex. There we go. I want this, which is the name of the type. Anything else afterwards, I don't care about. What I need to do is instance simplifiable of this name \2 \1 actually. Yes, there we go. Where simplify of that type name and I decompose it to get the fields is gonna be calling the constructor again, but with new oops, I went too early. New fields. Ah, yes, I need to do that. Yeah, I think that's correct. Oh, I seem to have two spaces instead of one. That's fine. There we go. Okay, so that's going to be the shape. Oh, except no, I messed up something. Let's try that again. Oh, because I truncated a bit too aggressively. This is missing the instance simplifiable \1 where there we go. Okay, and that's good now. Okay, and now we just need to fill in the blanks. This is okay. It's gonna be. This is gonna be boring work, but it's gonna be very straightforward. Okay, so in the case of a module, That's not module, this is here. The new simplified module will contain the same imports because they're not parameterized by... That's not the right syntax. Oh well. Mod imports, unmodified, and map simplify on the mod definitions. So we're gonna simplify each definition. A definition. What is a definition? It is one of those. So the definition of something will be oops. It's going to be taking one of those and is going to be then recreating the same thing, but with simplify type alias info is going to be the same thing, where we are going to recreate. So the alias name doesn't change. The alias params doesn't change, but the alias value becomes map. No, it becomes simply simplify do I want I was gonna say, do I want to do coercion on things that I know won't have any simplification instance? Like a type alias info doesn't have any... Yeah, I think I can probably simplify a lot of those. I think I can try this. I think for now, I can replace all of them with coercion for now, because the compiler will be able to prove that they are the same type. And that means every branch that I know doesn't need to be implemented. I can just do a coerce. Let's try. What happens if I replace equals something like this with coerce? Okay. This should actually work. Let's try to compile this nonsense. Let's see. Okay, so module here needs to be module passed. That's fine. That's in the parser. If I go back to the parser, I have somewhere here that says module. There we go. This is now module passed. And I have here module parsed as well. That's it. Okay. Okay, so that seems to be compiling. Except I still have somewhere... Oh, in the parsing file itself, of course. Here. There we go. So here, this is a name type simplified, which should be known to be the same. Did I? No, I did change simplified. Okay. Ah, I forgot this one. Yes, of course. Here, I need to also say that the AST representation of simplified. There we go. That's what's missing. Another question is, will the new simplification phase compile or not? Nope. Ah, function archetype doesn't have. Yes, of course, it is a, yeah, that's fair. Okay, and likewise for statement, that makes sense. Where are you, statement? Actually, I'm gonna... Oh, I'm an idiot. Okay, I need to change more than this. I can actually keep this change. But now I need to change... that basically from this point onwards, simplify whatever is in the middle, doesn't matter. Equals coerce. It needs either I need to give the argument to coerce, or I need to just say simplify equals coerce. There we go. A simplified. Aha. So this is an annotated thing, so I cannot simplify. I will need to do some within magic in there. Except I know what the thing is location. Is that a functor of the with location? It is. Okay. So that is, I am doing an F map of simplify on the mod definitions. I have a list of with location definition, and I'm applying simplify on the thing within the thing within the thing. So F map of F map. Okay. Coerce is not in scope, and I believe it is just data coerce. Who goal to the rescue? Coerce, data coerce, yeah. Nope, it doesn't work. So why not? What is the issue with data coerce? Because values of types that have the same representation. That's interesting. That means that since I have non-injective type families, coerce is not able to realize that the types will be the same and will have the same representation. That is annoying, but not that surprising. Okay, so that means that we go back just a bit to before we did all of the coercion. There. And we fix what was wrong. This is an F map of an F map. There we go. This hasn't changed. Okay, and now all of those things are gonna have to be defined manually. That's fine. So a type alias info is going to be a type alias info indeed, where the alias name is unchanged, the alias parameters are unchanged, and the alias value is a simplify of the alias value. This is going to be a lot of no-ops, but oh well. Enum info is going to be even more straightforward because it is literally the same field, nothing has changed. Struct info is going to be whatever a struct info is, which means it's going to be a struct name, struct params, struct values, for which we are going to do an fmap of simplify. Actually, this could be a good use of lenses. This would be a fantastic use of lenses. Let's try that. Because this module here, simplify on a module, is... Yeah, this is going to be a lot easier and a lot less repetitive with lenses. Because I have lenses on all of those types. So this is simply mod definitions. And it's going to be something like traverse, probably. Traverse, because location is a functor as well. And I am going to apply a function, which is simplify. This is probably going to be something along those lines. It's been too long since I've done that kind of traversal with lenses. Let's check whether this is correct or not. Well, it fails to compile at a later stage, which means it's probably fine. Let me try just to comment all of this. Ah, yes. Simplified. Ah, there we go. Yeah, it's not traversable. Okay. But there is no reason why it can't be. Okay. Okay, I'm gonna replace this with undefined just to check that this lens nonsense compiles. Unused imports. Perfect. So yes, this is good. So we can go back where we were, which is here. And now, okay, it means for a lot of those things, rather than listing all the fields manually, I can write this with lenses. There's probably a way to do this with prisms, but I'm not familiar enough to know how to do this kind of case with prisms. We need to check that out. I'm not sure. Okay, but for a type alias info, for instance, this is going to be very simply simplify is I go for the alias value and I apply simplify. For an enum info, I'm annoyed that there's no way for an enum info coerce should work because there's nothing that depends. So it should realize that the thing have the same. Yeah, it should work. Because here there's no type family at all. So it should realize that the runtime representation of enum info passed and simplified is the same, and therefore coerce should be valid. Okay. Without the problem of the non-injective type families. Here, struct values, traverse the list of non-empty, traverse the tuple because tuples are functors, and the function that I apply on this thing is simplify. There we go. That is so much better than what I was writing at first. Const info, the only thing... Oh, no, two things change for const info. So this is going to be the combination of two functions. Maybe I'm not going to be able to do it with the lens here. Because if I apply a first function, I would return a new thing, which is a type where the two fields are different, and that will not work. So for const info, I think I can't do it with lenses. I'm going to have to do it manually. Const name. Or at least I don't know how to do it in a way that avoids type issues. So here I'll have to do simplify const type and fmap simplify const expression. Function info. I have the same problem here, which is that there's more than one field that has this. If I had a way to do a lens on all the things that are simplifiable, I could write it with lenses, but I don't have such a lens, and that would be basically doing what I'm already doing. So I can't reuse code here. Might as well do it properly. This is therefore fun name, fun params. Those do not change. For the fun arguments, we are gonna have an fmap of an fmap. I should introduce some kind of fmap2 or something, given the amount of time I do that. Of simplify on the fun args. A fmap simplify of the fun return. And fmap of simplify on the fun body. I wonder if I could also try to see if I could write generic instances for all of this and use generic for this, but at the same time, that would be a lot of boilerplate to then reduce boilerplate in this file, but it's boilerplate in one place, basically, and I don't think there's a lot of value in trying to like remove this kind of boilerplate. That's fine. Okay. Function type, what are you? Function type, you have more than one thing with the thing. I can't use lenses elegantly here. Therefore, this is fun type params. This is an fmap. I should really introduce some kind of fmap2 or something. Of simplify. On the fun type arguments. Nested fmap because it is a pair within a list. Yeah. And for the return, that is something within a maybe. That is a simple fmap on the fun type return. Function archetype, what are you? Function archetype, you are one of those where I need to do a case. You are either by value, in which case this is by value of simplify, or you are by reference. Okay. Variable statement. Statement is going to be another case because it's one of those. All of those are going to be info, and it's going to be the same constructor applied to simplify info. That's a ton of boilerplate, but oh well. It's mostly, but it's just boilerplate because in most of those cases we have nothing to do, basically. In the case of a return statement with an expression, that is a maybe it is a nested fmap again, so it's an fmap. So it is a return statement of fmap of simplify on the expression. Continue statement is continue statement. Break statement is break statement. And an expression statement is a single layer of fmap. It is an expression statement of fmap simplify of the expression. I'm going to group those two together given the similarities. There we go. Okay, if info, let's see, what do we have here? All of those fields are parameterized by the phase. I can't use lenses for simplification here. So this is fmap simplify if exp fmap of simplify of if body fmap of simplify on the if else. I wonder if there's a way with lenses to do something smarter than this, but I don't think so. Because if I were to use a lens on something to just change one of the fields without changing the others, I would end up with a type that's not correct, and I don't know how to combine lenses to do all operations at the same time. It is probably doable, though. Let's have a quick look, because that would make a lot of things easier if I could. How to combine lenses in parallel. Let's see. What do they mean here? Oh, there's a lens product that seems to be... There's lens product. I can have a look at lens product, although it's not likely to be guaranteed to be what I want. But still, worth having a look. Control lens. It was, I already forgot the name of the thing we saw because my brain doesn't work. It was lens product. I don't know. Yeah, let's have a look at Google to see in which module it happens to be defined. Lens product in control lens unsound. Ooh. If the input lenses project disjoint parts of the structure, I think that's what I want. Yeah, I think that's what I want. Let's see. Would this work? Let's try to get this to a stage where it compiles. Just so I can open GHCI. No, actually, I'm gonna do something else. I'm gonna do this, and I'm gonna do this, and I'm gonna do from here on out equals undefined. There we go. Okay, so that should compile. Almost. Except else info is not okay, so I'm just gonna do that instead. An expression doesn't have one constructor, so I can do that instead. Okay. Let's have a look at this. This compiles minus the problems of... okay, I'm gonna remove them real quick. Because those are warnings, but I always work with W error. Okay. This should compile now. Or at least this module should compile. I am missing data coerce. Unused. Okay. So I want to check whether lens product is what I want. Expecting one more argument to module. Yes, that makes sense. Here I am generating arbitrary things for the past version. So the tests need to compile as well. Okay. To module. This is a module past. No parenthesis needed. And here is main, where things don't work yet. Okay. And that's fine. I can do that. So I have, this is parse module. That gives me the past AST. I can do a let simplified AST equals simplify module of the past AST. And then this is done not on the AST, but on the simplified AST. We have added a new phase to our operation. Perfect. Simplify module not found. That makes a lot of sense. I would need to go to... I don't think I have... Yeah, okay. I'm just going to put it in there then. Stages parsing, and I'm going to add stages simplification. There we go. And that should compile. It compiled with all the undefined, so it doesn't work yet for what we're trying to do. But that means I can now do a stack GHCI, get access to a GHCI with all of the things that I want. It needs to recompile a few things, so it's going to take some time. Okay. So now I want to import control.lens.unsound, which is always good. Now, what I want to check is this. Do I have past in scope? Yeah, okay. So let's define a type foo with two fields. X, which is path info past. Well, foo of P, which is an AST phase. Well, actually, I probably want to use a type that already has fields. Let's look at the AST. I probably want to use a simple type, such as, what do I want to use? Let's do for info. Okay, so there's two things that do have a parameter there. So I want to do map list functions and evaluate them in JavaScript and then putting the result back into the AST. Well, yeah, it's not that shocking. It's just like you're not dealing with the same level of like structure as a Haskell code, I suppose. Because this is basically what we're doing at the moment, right? This is like all of the simplification of like, oh, this is an expression we can compute at compile time. We compute it at compile time, except we do it rather than doing it on the raw code, we are doing it on the AST version, which is extremely verbose. But yeah, when you're doing an interpreter, you're a bit more dynamic. You have a bit more freedom to do things like this. Okay, just me think about this. Okay, here's what I want to try. When I do a lens on a type like this, like on a 4-range expression, for instance, if I try to change it, to change the type of P here, I cannot apply just that lens on that thing because it would change the type here, but not for the rest of the type, and therefore would not be a valid way to modify a for info because this thing would not be changed. Ah, nice. I'm convinced this will not work, but I have to try. So that would be basically doing a lens product of for range expression traverse simplify and for body and traverse dot traverse simplify non-scope simplify. Okay, so this is purely a matter of control.lens not being scope, and of course simplify is not in scope because in simplification it is not exported for convenience. I'm not surprised that it's just, can I just not load? Maybe I can just do that. Yeah, that's the problem. Each lens individually is not valid, so the lens product makes no sense. That is the problem. Okay. Well, the good news is I can't use the thing that is defined in lens unsound, which is always better than using something labeled unsound. And I think I could try to find a solution, but it would necessarily require doing a lens that iterates over all the things of the same type at the same time, which would be basically doing the boilerplate once to avoid writing it once. Therefore, there is no point in doing that, and I should just write the boilerplate once directly where I need it. Okay, it was worth a try. It was worth a try, so that means we go back here. I'm just gonna... I don't like the way this is structured. Since no one else than me is working on this project, I can align vertically as I want, because no one else will be creating git diffs. There we go. Okay, so that was if info. Now I can look at the rest. I have else info, and that is a simple case of else if info becomes else if of simplify of the info, and else block with some statements becomes an else block of fmap of fmap of simplify of the statements. Do people define fmap2 something? No, fmap2 is not something. ffmap? No. I wonder what a common name for a nested fmap would be. Like an fmap of an fmap. I know some people have defined this. but there's a lot of overlap between this thing. Yeah, this is one I had in mind, where like you have two level of functors. Oh, I think some people have also defined this. But it's slightly different. Ah, no, there we go. In protolute functor, this is what it is. But if I were to give it a name, I think ffmap would not be absurd, but I don't think this is a commonly used name. And fmap2 seems to never be used. Is this because there's already a better name for this? No, if there were a better name for this, it would not be defined as an operator in so many places. That being said, I can have a look. If I have a function from A to B, and I have an f of g of A, and I want an f of g of B, it's only giving me the operator versions. Okay. So no one seems to have commonly defined in at least a known set of stackage a nested f map that is not defined as an operator, which means I am basically free to name it whatever I want if I'm defining my own, because I'm not going to be going against. I am not going to go against what people have decided because no one has made a decision on this point. Okay. How many times do I have not that many times actually. And do I have a lot of traverse? A few, not that many. I'm kind of tempted to like name them because that's a pattern that I do more than once in more than one file. Let's quickly stack something on top of the thing on top of the thing and go to my prelude. This would be then nested operations, I guess. And ffmap would be for some functor f and some functor g. For a function from A to B and an f of g of A, return an f of g of B. And ffmap is fmap. But traverse makes no sense. It's not t-traverse. Would that be traverse2 then? Has anyone used name any of those? Let's see. Traverse2. That exists, it seems. I don't like this notation. I think I prefer, if I'm gonna be defining both, fmap2 and traverse2. I think that's more consistent. But just, I think this just requires traversable. If it's not, the compiler will let me know. Okay. Stuff added on top of the stack. That means I can replace all instances of fmap.fmap in this file by fmap2. There we go. Okay, and with that, we're mostly done. Can also mean I can vertically align all of those fmaps near an fmap2. Starting to look better. Okay. Next, we have a for info, and I still can't use a lens for this one, sadly. Simplify of a for info is a for info in which the for variable name remains unchanged, the for range expression becomes an fmap of simplify. And an fmap to of simplify on for body. Okay. I still think I will want to do for expression, which is the whole point of this is simplifying expressions. I think I will want to use the the plated instance on expressions, which means they will remain on the past type and then do a very, very basic simplification on top that converts them into the right type at the end. While info, okay. Okay. Let info. The thing is, I think doing all of boilerplate is probably preferable in the long term, just because, again, there would be no point in doing any simplification there, like any boilerplate otherwise to simplify this, because there's nowhere else I'm going to need that. And also because if we ever find something else that needs to go in the simplification phase, then we can replace the boilerplate rather than having to move it. So I think while this was long and a bit annoying, I think it was worth it in the end. This is an fmap simplify on the let type. On fmap2, no, that's a regular fmap there on the let expression. Path info is the one I am gonna... Expression is what I'm gonna keep last because expression is the one this is all about. Simplify on a path info is gonna be a basic recursive thing. What is a path info? Where are you? There you are. That is simplify path name. Wait, no. I don't need to do that. That's the same type. I can just do path name. Where does name type appear, actually? Are there other places where it's going to be the same? Only in path info. Okay. So it doesn't need to change, which means in the case of path info, the lens should work. I should be able to write simplify, hopefully, as being path params traverse is simplify. And that should be fine because the name type, that's going to be the same type on both ends, and therefore this lens should compile. Okay. And now expression is where this becomes interesting. Because expression becomes I will want to do the plated thing and then do some kind of coercion. Let's have a quick look at how plated works again. Because I have already defined the instance. Plated is for self-recursive things, like an expression contains sub-expressions and so on. I have already defined, like an expression is even literally the example they give. I already have an instance for it, which means I have rewrite. Rewrite is given a node, an A function that turns out maybe A, will apply it. Okay. What's the difference with transform? All right, so purely, okay. The only thing I want to check is rewrite. Oh, okay, so it returns maybe is not the node should be erased, maybe is just there's nothing to perform, basically. Okay. Yeah, transform is probably good enough for what I want to do. Okay. So we are going to want to do a coerce expression of transform of a simplify expression. And this whole thing, specifically this thing, is what this entire file is about. All of this boilerplate just for that. Coerce expression will be a very basic function of an expression passed into an expression simplified. And I am very, very, very tempted I am extremely tempted to say unsafe coerce. Because the compiler will struggle to figure out a coerce instance there. Wait. Wait. Is it enough to delegate the coercion constraint to the caller? Can I do data coerce? What's the name? Coercible. Can I move the constraint that those have to be coercible up? If yes, then I can rewrite a bunch of things that do not contain expressions as coerce. This would be back into the AST. I have the show constraint here. There we go. Actually, it's too specific. I'm not going to put that in AST. But that would be basically coercible name type passed into name type simplified. If I do that, if I move the burden of proof to the caller, can I write coerce expression as coerce? I wonder. Okay, but in the meantime, simplify expression is the one I want, because that is what this entire file is about. What I want to do is write all of the cases where we know we can simplify an expression here. And no type checking needs to occur, no name checking needs to occur. This is purely AST transformation, and then the analysis thing will go back to doing its job. But now when I deal with like, hey, do I have this value at compile time? Do I not? I don't have to like do all of checking of like division by 0 and all of that in all of the branches and do all the checks of the type of the things in all of the branches, because I will just have done this simplification here, which means after that I am either in the case where like I am either in a case where both values are known at compile time but could not be simplified, and that's fine, we can do the thing, or at least one is not known at compile time and is not one that could be simplified. We're in the basic two cases that we've been handling so far. So this becomes when we have an addition exp in which the thing on the left is an int literal 0, and there's a right-hand side, this becomes right-hand side. Except, oh god, no, that doesn't work. The plated instance is wrong. I'm gonna have to change something about the plated instance, because the problem is that the plated instance is on the expression, and that is not correct. Where are you plated? Yep. The problem with this is that I don't want to do the plated on the expression, I want to do it on the annotated expression. So let's stack more things onto the stack. This is does that mean, yeah, I'm gonna have to change my instance of simplify to be on the with location expression. That's fine. Because otherwise the location information will be wrong. Okay, well, so let's rewrite this. I think that's just that every single call to within is no longer required. Because I will want to replace something with a location with something else with a location. Yeah. That's what I need to do. So within f becomes f. Within f becomes f, I think. We'll see very quickly if that was correct. And now that means that I don't have an instance of simplifiable for expression. I have one for with location expression. Oh, God. Which is not compatible. Ah, goddammit. Which is not something I can express with the type class, which means I can't do that, which means I have to instead introduce simplify expression as a standalone function, and that's going to be the function that takes a with location expression passed and give me finally a with location expression simplified, and this is going to be coerce expression of this. And finally, when I have some with location where I have this. Can I actually do something where I ignore the with location? No, I need the location because I will need to recreate it sometimes. Yeah, I think I have no choice but to do this. Okay, so I have at some location, whatever, an addition of 0 with something else, return the something else that contains its own location. So my AST will still contain the right location thing, even though I have removed this 0 plus from it. This right-hand side in the tree will still be pointing to the right location because the location has been properly... Okay. So now I can do the other way around. If I have a left-hand side and a 0, I can at compile time replace that with the left-hand side. If I have a subtraction expression of the left-hand side on 0, I can replace that with just the left-hand side. If I have 0 and a right-hand side, I can replace that by, at the same location, a int negation expression of the right-hand side. If I have with a location a multiplication expression of a left-hand side with an int literal 1, I can replace that by the left-hand side. If I have at some location a multiplication expression of a 1 with a right-hand side, I can replace that with the right-hand side. If I have a division expression of some left-hand side by 1, I can replace that by the left-hand side. If I have a with location something of an exponentiation expression of a left-hand side with an int literal of 1, I can replace that by the left-hand side. And all of those happen before analysis, therefore I don't need to do type checking to check that this thing is the correct type. This will be done as part of the analysis. I can write this purely as a transformation of the AST. If I have a with location of an end, a Boolean end expression, where the left hand side is false, those actually short circuit. Oh, but I probably want to. Those I probably don't want to implement here because I still need to check them. I can't just delete them. I can't say false and something that is wrong for an false and x in something where x doesn't exist. I can't remove them here. I can simplify them during the analysis phase, but I can't remove them here because then I would not analyze the thing properly. Excuse me. However, I can say that if I have true and something, then that will always short circuit to whatever is on the right hand side. Okay. Is that correct? Yes, okay. And if I have an OR expression with false on the left hand side, it will always short circuit to what is on the right hand side. Okay. Are there any other operation where I can trivially remove things that don't need to be analyzed as part of this phase? Let's look at the AST. I guess an int negation of an int negation can be replaced. There's no need to check, like, it's gonna be negation of negation is gonna be the same value overall anyway. So I can just remove the double negation. The type checking will still need to occur for whatever the thing it needs to be an int anyway. So negation of negation can be removed. I guess I can also remove equals true, I suppose, because equals true is something that would evaluate the other argument to a Boolean no matter what for the comparison to be valid. And equal true would be evaluating to a Boolean. So no matter what the context is, that thing is a Boolean. And therefore equal true can be simplified to just being the same thing. So I guess equal true can be simplified. Equal false can be replaced with a not. Oh, I'm gonna stack something on the stack. Actually, put it in the queue. I'm not gonna stack it yet. I'll have to check that in cast expression if I know that the type I can probably make this a no-op if I know that the type is an int. But that's a problem for later. Okay. I guess the other thing where I could make is the multiplication assignment and addition assignment. Oh, sorry, I had missed your message. No, the video feed is added by OBS. It's not in Emacs directly. This is just a buffer that I have named video feed so that it looks good on the stream. But I could have any buffer there. It's just an empty buffer. And actually, I have a somewhat complex setup. I used to like I'm working on my laptop because my laptop is my usual work thing. The problem is it's a bit old, and running OBS on purely the CPU is not powerful enough to like it's fine as long as the temperature doesn't rise too much and the CPU doesn't get throttled. When I used to do the advent of code in the winter, it used to be fine. In the rest of the year, the temperature gets too high and the CPU gets throttled, and OBS just absolutely crash. So the very first stream of this project, my computer died after an hour, so I didn't do a lot. So what I'm doing is I'm using my capture card, actually, to capture the output of the laptop, and I'm running OBS on my gaming PC, which is significantly more powerful, and I'm using the webcam and everything connected to my gaming computer that is running OBS and using the feed from the capture card connected to the laptop, which is, a non-trivial setup, but it works. And yeah, no, I'm not running the webcam is not in Emacs. I could have tried, but it's just OBS. I was trying to think. I think for the assignment expressions, like a multiplication assignment, like a times equal 1 or a plus equal 0, I think those could be safely removed. I don't think they do anything. The problem is that they do assignments. So here this would be removing the entire expression. This will depend on how I implement what the return type of an expression like this is, because this could end up being a simplification that happens at the statement level. Like this statement does nothing, therefore it is removed. But the problem is if I do that, I'm going to end up not type checking the thing properly. So I think this is something I should do as part of the like tail code optimizations and like IR optimizations where like this thing does nothing, and not as part of the AST simplification. Okay, so no changes of the assignment expression as part of this phase. So the only thing I said I wanted to do still on this was negation of negation and negation of negation for sure. And what else did I want to do it on? There was something else. What else did I want to do the same thing of like using a negation instead? Not one of the literals, not the reference. What did I want to do here? There's something else I've mentioned that I wanted to do, and I cannot for the life of me remember what it was. Ah, yes, equality with true and equality with false. Those I can do as well. Because those are trivial rewrites that do not remove any information. Okay, so negation equality of booleans. that's it. So, if I ever encounter a Boolean negation expression of a Boolean negation expression of some expression, I can replace with that same expression. Even if that thing is not known at compile time, because it would have to be checked to be a Boolean any... wait. I'm starting to think that none of this works. And the problem with this is those rewrites, while correct in theory, might result in some errors not being detected properly. And that's because if I replace a negation expression of a negation expression by the underlying expression, if someone had written something like this, not of x plus 1, with x being an int, this should not compile because not of x is wrong, not expects a Boolean. But if I remove not of not because that's a no-op, and I replace it with x, and x is an int, then suddenly x plus 1 is well formed. So this simplification cannot happen before type checking has occurred. And I think the exact same problem happens with all of the others I've done here. For instance, if I have not of x times 1, and I'm like, oh, that's just x. Suddenly this type checks if x is a Boolean, despite the fact that this would not have. So I think the last hour and change we can trash. I think this idea of simplification was not a bad idea, but I don't think it can be done without also doing the type checking. Therefore, trying to do it ahead of time on the AST so that, okay, we've removed the things that are obvious and now we type check everything. Nope. Nope. That doesn't work. If anything, we could consider... If anything, we could consider doing it afterwards, actually. Doing this simplification phase after the resolving phase. And it's like, okay, we've type check everything, so we know that not x of 1 is valid. And now we can simplify it. The upside being that we are not obligated to type check every single branch because we will have type check everything. Does that mean we do not do constant unfolding at all? And we do it all afterwards? No, I think it's better to do it during the analysis phase. Yeah. Sorry, I'm only seeing your message now. That's what I'm thinking of, maybe keeping this and moving it after type checking then. But does it offer a lot of benefit? Like, does it still remove... I guess it does remove a bunch of branches. It's like, okay, we've checked all of this. Now we can just simplify it. Yeah. But I think the constant unfolding still need to happen during during the analysis phase because I want to be able to report like division by zero and exponentiation with a negative exponent, that kind of stuff. So this simplification on should only happen for things that do not. Yeah, I can't do constant unfolding as part of this phase. The constant unfolding has to happen as part of the analysis, I think. Okay, so let's change this. This is no longer going from parsed to simplified. This is going from resolved to simplified. Everything else should be literally the same. The difference being that for expressions, we don't have with location, we have typed expression. Which is not correct, I think. Because it means basically those things have to become same as this one. In which case, actually, if we move the simplification phase after type checking, then we can do a lot of things like removing statements that do nothing and so on, because at that point, the type checking has already happened. So removing a times equal 1 because that does nothing is fine because we've already type checked that a exists and it was actually an int, and therefore a times equal 1 was well formed. So moving it after type checking actually gives us more leeway. So I think that is the right move. Okay, so this becomes definition resolved, still located. Statement becomes statement simplified. There's no annotation, it's the same thing. Does that mean that the things I get... No, when I get other modules because I'm doing from the import thing, I think I should still get the resolved version because the simplification is a form of optimization that only should be in the pipeline for a given module, not the version that I keep for other modules, I think. The thing is, I never depend on the actual expressions. Actually, no, for constants. For constants, I will want to actually get the simplified version. But that means changing so many things. So I think no. It's going to be... I'm going to still depend on resolved for other modules, and the simplification will be applied on one specific given module when I'm compiling it. Okay. So this becomes the same way, and this has to move elsewhere, which means now this is a role for simplified, which I'm going to move below resolved. Okay, and the last... okay, that's a question that's gonna... Cards on the table, I am strongly anti-LLMs for a lot of reasons, and I've tried to use them for coding even, but I am firmly on anti-LLMs for a bunch of reasons. On this project specifically, I think it would be a bad idea, in the sense of like the whole goal of this project is to be somewhat educational, of like, here's how, like, going through the steps of making a compiler goes. If I were to ask, if the streams were me asking an LLM to actually write the code for me, if I were to do anything but the boilerplate, it would ruin what makes this project this project. So for this project specifically, I think it's not a good idea. For me as an engineer, I like writing code. I think it's something that like the whole process of understanding the thing I'm trying to do and putting it into like code is like the whole core of the thing I do. And delegating to LLM, like we know study after study that the more you delegate a task to a machine, the less good you become at the task. So even if you review what the thing does, you're no longer able to justify the reasoning that went into it because there's no reasoning that went into it. So except for very, very small cases of like maybe boilerplate, I am not convinced that it is a good idea to give like coding tasks to an LLM, even if they were good at it. Third thing is they are not good at it. They get lost extremely quickly because LLMs are not smart. They don't think, they don't reason, they output probable text. And probable text, when you have a large corpus of data, can be correct. But can is the operative word. They hallucinate. I don't like this term, but it's the term that is commonly used a lot of the time. Even recent models hallucinate upwards of 60% of the time on things they have direct data for. So that means that as soon as a project becomes a tiny bit big, those things get lost and they get pretty bad at writing code, especially if you're not writing something for which there's thousands of examples on GitHub, which means they tend to be pretty good at prototyping a very basic thing, but for any more specific task, they're not that good, and I don't believe they're gonna get any better. Beyond that, there's also the moral and ethical implications of using LLMs. And while I think it is possible to at some point be in a world where it's ethical to use them, I don't think it is ethical to use them in their current form. There is the environmental concerns. It's difficult to quantify the environmental cost of running queries on an LLM. But what we know is if we look at the bigger picture, most big tech companies had commitments to reduce their carbon emissions over the last few years, and they've increased 30% instead because of the demand, well, artificial demand, but that's a second point, of LLMs. So those things are literally driving an increase in carbon emissions of companies that had sworn and were on a downward path. So there's an environmental concern. On top of that, from an environmental perspective, those things are requiring a bunch of new data centers to be built that happen to be often built in poor and impoverished areas where the land is cheap, which means currently LLMs, as they are today, are poisoning poor communities. The XAI data center is making the air unbreathable in the poor communities where it was built. So there's the environmental concern. There's the labor/copyright concern. Copyright is a super complicated topic that I'm not well versed to talk about, and I don't want to say like copyright is all good or copyright is all bad because again, too complex, and I don't know enough to have a well-formed opinion. What I can say, however, is that if I, as an individual, were to pirate, one or two Nintendo games and put them online for my friends to play, I would spend 20 years in jail and spend millions of euros or for the rest of my life trying to repay for those two games. And I can say that for sure because it has happened for someone actually named Bowser, which is kind of funny, except it's not, who's like months in prison and spending millions and millions of dollars to repay Nintendo. Meanwhile, those big AI companies are taking everything that they can, including a bunch of material that's illegal to possess or things they have obtained unethically, and they don't even get a slap on the wrist because they're making AI, right? So there's this problem of like unethical access to data that I don't want to frame in terms of copyright because copyright is a complicated issue, but clearly the data was not obtained ethically. There's also the labor issue of those tools are trained on data taken from people whose work it is to create it, writers, artists, whatever you want, and then used to replace them and take their jobs. So this ethical access to data and labor issues kind of make using the big LLMs at the moment kind of difficult. And last but not least, there's also the problem of like, and that's a bigger that's a problem that's less because of the LLMs themselves and more the companies that make them, which is that a lot of the big companies that make LLMs are currently, well, how do I phrase this? Not really opposed to what the US government is doing, and to say it explicitly, they are components of the rise of techno-fascism in the West, and as a result, sure, a tool is a tool and you can use it for good and you can use it for bad, but if paying a company to use the tool means putting money in the pockets of the people who want to create techno-fascism, I am not incentivized in actually, giving money to those people. So for all of those reasons, I do not want to touch LLMs, and I will not use them. I would not use them even if they were good, and I also do not believe that they are actually good. It is my personal opinion, and I could be wrong, that we are about, but I don't know if it's like a matter of months, weeks, or years, but we are currently in an investment bubble. Everyone is banking on LLMs making hundreds of billions of dollars in the 2-3 years to come. That is absolutely unrealistic. They do not deliver on the promises. They cannot do the things they promise. Most people hate being forced to use AI everywhere. Therefore, those billions of revenue will not happen. Therefore, those billions of investments will be lost in some form, and that will be the explosion of the bubble. And that is going to be pretty painful when that happens. I am fairly convinced of this. I could, of course, be wrong. I'm just one person on the internet, right? Yeah, and again, I think they can be good in very small things. Like, I think the second you start having a large project, I don't believe they can actually be good. Because, really, again, they're probabilistic models, and they're going to be good if they have a lot of data like to mimic in their corpus that matches the thing you're doing. The second you're doing something a bit new, the second you're doing something a bit big, the probabilistic model is not able to do anything anymore. Like, even Microsoft, like on their GitHub pull request, where they try to make the thing like automate pull requests, it's bad very quickly. I am not convinced. I am not convinced LLMs will ever be good for large-scale coding. Where all ethical concerns aside, it makes us less good at our job because we are delegating the task to a tool rather than making the effort ourselves. Even if we were to ignore all of those concerns, there's one very, very specific case where I could see LLMs be good, and that's boilerplate generation. Because basically you don't have to write regex or macros or things, and you can just ask the thing to generate a boilerplate when there is a gigantic corpus of boilerplate to learn from. That's, if we were to solve all the other issues, would be a thing where I think LLMs could be good. But even then, like, it's generated boilerplate and then you modify it because it's not okay by default. But yes, otherwise, the LLMs have, to some extent, the exact same problem as crypto and NFTs, which is like interesting innovation on paper, in practice only used for like nefarious purposes, right? There's no good use of those today beyond scamming people or generating slop or like generating misinformation. There is no real good use of them. So, all that to say, I am not convinced that they are a good tool for programming. And even if they can be in some context, even if I can see a world in which they have a very specific use, there are so many other concerns around them that I will not touch them. Well, they're not entirely gatekept by the big tech companies, right? There's also the thing, how was the one from China, the open source one called, that came out 2-3 months ago? It was a gigantic shock. Was it DeepSeek? I think you might be right. Yeah, that was like trained on a fraction of the cost. So it's not. There are some open source models, but a lot of the same ethical thing applies. You don't have the problem of like the money you give to them goes to like techno-fascists because they're open source models. You don't give money to them. but all of the ethical labor problems, the unethical data that was obtained, the fact that again, like most of those models that exist today have been trained on data that should not be in there, including CSAM. So it means any model that you run can output stuff that you really, really don't want it to output. And the only like guardrail you have today is to say, please don't output anything bad. And we have seen on Twitter 2 days ago how a very small change in prompt can suddenly make all of the bad stuff come to the surface. So, for all of those reasons, no. My personal opinion is very much a no one should use LLMs at all. There's no good use of them. There is no ethical use of them. That's a very good. I know I had seen a thing. I think it was on Reddit of someone being like, "Hey, it would be super useful for us to use the actual Microsoft drivers for this, but they're not open source." Well, the license they are, but the license is not compatible. However, Copilot was trained on them, so we can just ask Copilot to generate the exact same code, which is going to be like 90% correct, but we can just change it. And that's Copilot generated code. It's not the licensed Microsoft code, and now we can use it. Absolutely fantastic. But yeah, like again, this copyright is a complicated thing, but yes, licensing, access to like ethical access to the underlying data, most LLMs today just ignore that completely. So and now I have to figure out what I was doing. I think we're moving the simplification phase after the resolving phase. Yes, that's what we were doing. I mean, I'm always happy to talk about those things. The thing is, where I want to be very careful is when I say stuff about compilers and Haskell, I have some legitimacy. I've been working on those things for a while. I've been using Haskell for a decade. I will say, like, if I say something about Haskell, it's not guaranteed to be true, right? I'm just one person that can be wrong, but I am fairly confident in what I say. On a topic like LLMs, it's too new for me to have the confidence to say my opinions are like to put some weight behind my opinions. Suddenly I go back to just being someone on the internet whose opinions you should probably disregard, right? I want to be very clear about this. Like I'm not putting the weight of my career behind those statements. That's more opinion. But I still think it's important to think about, especially because, again, I strongly believe we're about to witness a crash, like a financial crash because of this. So, and also, us working in this industry, we are going to have to maintain in the future code that has been written by LLMs during this few years of them being used everywhere. And that's going to be a security nightmare for decades. So, yeah, we have to be aware of the consequences. I'm kind of wondering if within is actually still used at this point. Do I still use within at all? I do for the prettifier. Okay. So it is still typed expression. Okay, that's fine. Wait, no, it's not. Oh, actually, could I do that? Could I say that within... Oh, I could do that. I could say that within a simplified module, the type of the expression is a resolved expression. The upside being I don't have to do all the coercion, but at the top level, the modules still need to go through the type level. The type system still reflects the fact that we have gone through that phase. Or the simplification phase does not change the type of the phase. It is purely an operation on a resolved module. And I don't need to reflect a change of phase in the, because it no longer become a requirement. Yeah, maybe this is better actually. That means I remove the simplified thing altogether. We go back to the two phases we had. And remove simplified altogether. Okay. That means that I need to go back to... That means I can change... I can change module back, so I can undo a bunch of things I've changed. So this is going to be, I can probably just go through Git and my Git diffs and remove all the module related changes. Because suddenly that's no longer something that's required. Simplified no longer exists. Because since at this point, yeah, since there's no need to have done the simplification phase to go into the analysis one, then this becomes purely a matter of like reflecting the change in the type system becomes less important. And in fact, we could decide to turn off this simplification phase in some kind of debug mode, in which case it's much better for the types to not change. So we remove simplified, which means we need to go back to stages analysis here, and also the boot files, and also this one. And we are gonna need to do a simplified to past. Okay, so we're back. We're basically back to where we were. I might be even able to delete those fmap2 traverse 2, which would be nice. Yes, those changes can go away. This goes away. However, the plated instance being on the... No, the plated instance can go back to being on the expression. I think, because since we do this at a point where we no longer have location, the only thing that matters is the type. The annotation is the type. And therefore, we can always replace the type. So plated can go back to being on the expression, which makes, I think, a lot more sense. Which also means I can write my transform in terms of transformation on expression rather than transformation on annotated expressions, which I think is a lot better. So this goes away, which is always good. This stays. This goes away. This goes away. This goes away. This needs to change. Okay. Let's change this now. That's gonna be here. The result is what I'm gonna call instead resolved AST. And simplified in AST would be simplify module of the resolved AST. And result, oh, I have, that's a maybe. Okay, so I need to do that at a later point. Do I do this as? Well, I guess I can just simplify module on this. There we go. And then everything remains the same. Okay. Which means now, the only thing we need to change, and now I can make everything with lenses because I don't have the time system issue anymore. Now I can go back to the simplification phase. This is neither pass to simplified, it is resolved to resolved. It is a simple operation on the thing. Which means I can even rewrite it as being that's a function from A to 8. It's an endomorphism of A, basically. That's fine. I don't need to do any more than that. Okay, so now I can do that. I can do that. I can rewrite this as being const type simplify and const exp traverse simplify. I don't need to mention the fields that don't contain anything, which is always good. Likewise here, this becomes... Hello. It's been a slow evening in the sense where 2 times now I've made an hour of changes and then I realized, actually, no, I'm gonna remove all of this. Which is always fun when it happens. It's mostly been a matter of... trying to find ways to do simplification, like AST transformations, basically. The example of what I want to do is, let's say there is Boolean negation of something, right? Obviously, we should be able to replace not of X by X. Semantically, it's the same thing. However, my mistake was, what I started doing is, I started doing it as part of the analysis phase. Or like, oh, this operator, part of it is known at compile time, I can simplify. The problem is that this was creating a lot of branches in the analysis module, and in all of them I had to do the same type checking and a lot of duplication, which was kind of annoying. So what I decided is like, okay, I go back on this and I introduce a simplification phase where I transform not of X, and then the analysis phase does all of its analysis and type checking, and I don't have to have a bunch of different branches as part of the analysis. The analysis does the type checking properly, but on the simplified version. And that is broken as well because of this. Imagine not X plus 1. This should not compile, because for this to be valid, X must be a Boolean, which means not X is a Boolean, and Boolean plus 1 doesn't make sense. But if x is an int, and I simplify not x to x before type checking occurs, suddenly x plus 1 will be valid because x is an int. Therefore, I can't do the simplification before type checking happens. So, after those two attempts, the solution at which we arrived is I am making this simplification phase after the analysis when type checking has occurred. And that way, I still get the benefits of separating the two phases, where during the analysis, I don't have to do all of those branches, treat them as different cases, and do type checking in all of them, which multiplies the risk of me forgetting one of the branches and not doing type checking properly. So I do the bare minimum of like, okay, generic case in the type checking, and then I have this simplification phase where I will actually simplify things that I now know for sure can be simplified because not x would have been rejected if x was not a Boolean in the first place. The only thing is I think I'm going to keep constant unfolding as part of the analysis because there are things I need to do there, such as detecting division by 0 and so on. I'd like to keep the simplification phase total in the sense of like I only do transformations that are safe, and as a result I don't want to do constant unfolding as part of it because constant unfolding is not, because if I resolve a big constant and arrive at the conclusion that actually no, it's a division by 0, I have to throw an error. So I'm gonna keep constant unfolding as part of the analysis phase, but it will still avoid having a bunch of branches in the analysis because I'm moving a bunch of simplifications in this simplification phase. And now that all of this is done, I am rewriting a bunch of things. Actually, I don't even need the chorus anymore. There's no need to simplify something that's already just the same thing, right? Okay. So I can rewrite a bunch of those things. And I'm gonna just rewrite them this way for readability. This is I'm not sure this is gonna be okay because I'm mixing and dot. I am not sure I can try in GHCI. I can try in GHCI if I have import. Is it data function? Yeah. And import control.lens. If I do, what's the type of f a function that given an x does x and const x dot traverse. Okay, it's happy with this. That's good. So I think that looks better. Okay, which means I can do the same thing here. This becomes given some I thing becomes. This one is not actually going to be a lot better. This one, since it's all the fields, I might just keep it that way. Yeah, maybe even the const info, actually. It's not the end of the world. Just don't need the enum info here. Okay. Since it's already written, there's not much of a need. I can just leave them that way, I think. Yeah, I'm not going to change them too much. I think it's the same anyway. And coerce expression no longer needs to exist, which is good. And I can go back to doing instance simplifiable expression, because now I no longer have to worry about location, because I'm no longer doing this at a stage where location is still a thing that matters. So I am back to this, where this is a transform, and that's all it is. Which means I can remove all of this. And here, none of those LHS, RHS are correct, because those are still annotated. Like in an addition expression, the left-hand side is not an expression, it is a typed expression, so it contains a type. But since type checking has occurred, I know that this thing is an int, and therefore I can replace this expression with the expression within. I know the type checking is correct, so this is the exp value. Likewise. And here, this is the expression, so the type needs to be the same, but that becomes an int negation expression that hasn't changed. That takes a typed expression underneath, which is this one, so that's all good. Exp value, oops. Except I have two of those, but that's fine. Okay, so let's recap. What I'm saying here is, when I have addition of something plus 0, I cannot remove the computation on the left-hand side because it might be performing side effects, but I can remove the plus 0 part of it. That part is useless. 0 plus something, I cannot remove the right-hand side part because it might perform side effect, but the 0 plus part can be removed. Subtraction of something by 0, I can just remove the right-hand side. 0 minus something, I can just make it a negation expression rather than keeping an int literal like this. Multiplication by 1, I can remove as well. Division by 1, I can remove. Division by 0 will already have been handled as part of the analysis. Exponentiation by 1, I can remove. I can short circuit and an OR with a left-hand side that is known. However, I cannot remove I cannot do the other case because false and something, I know the result is going to be false. However, the right... Actually, I could remove those, actually. Yeah, those I could remove now. I couldn't before because of type checking, but now that type checking is done, I can remove them. What I can't remove is left-hand side and false, because the left-hand side might perform side effects, and they need to happen because short-circuiting is from left to right, not right to left. But now, actually, I could, if type checking has happened, if there's a Boolean false, I can just replace that by a Boolean literal false. And that is post type checking, so we're good. And for the OR, put on a separate group. If it's true or something, it's always going to be true, so it becomes just a Boolean literal true. Okay. And now Boolean negation of something becomes just the value of that expression. The type does not change. It cannot change because the type checking has happened. Likewise, for the int negation expression of an int negation expression, that remains the same thing. And I could probably also simplify some of the statements, because the assignment, I still don't know what I want an assignment to be. I probably want, like, I probably don't want people to compose assignment. So a times equal 1 probably will be a unit type that cannot be assigned or used by anything. I guess it'd be assigned, but I guess I could reject let assignments of things that are units as well. In which case, an a times equal 1 could be replaced by a unit, and the statement of a unit could be removed. Like, at this point, we can remove a bunch of things because type checking has occurred. What else did I want to change here? If I go back to my AST, I guess cast of a cast I could also remove. If it's like cast to type to cast to type, like cast of int, I can just remove that. That being said, cast will probably mostly be a no-op at runtime, so there's probably no need to actually simplify it that much. Like, I think I'm only allowing cast for things that actually do not require changing, like have the same underlying representation. It's the same thing as the Haskell coerce. So cast will be a no-op at runtime. So removing cast of cast, probably not needed. Oh yeah, I wanted to remove the equality and difference. Because if I have an equality expression of something that is a Boolean, literal, true, and a right-hand side, that is simply, that is, the only way that it is valid is like I'm saying A equals true. That's the same thing as saying A. So I can replace that with the X value of the right-hand side. Likewise, for left-hand side and a Boolean literal true. And for false, this would be a replace by a Boolean negation expression of the right-hand side. Because A equals false is just not A. And I can probably do the same thing for difference. I could also consider replacing like more complicated things, but at some point, this is less pattern matching and more like broader analysis. Is it difference? It is difference. So that's, I just remove different from true means is false, so it means not. Different from true means false, so it means not. Different from false means true. Okay. Okay. That's good enough for now, I think. We can probably go a lot further on things that are useless that are getting removed. Like something that does nothing is a no-op. We have already type checked. We can remove, but this is already pretty decent, I think. Okay. Which means we'll have to make this compile. Not there yet. But it also means that I can go back to core And here, if I go back to what we started with, which is the analysis of functions, I can go back to subtraction being just a binary int expression, because either both values are known at compile time and I can simplify them. But I can do also assertions at this point because some of those things might fail, like division or exponent. Otherwise, regardless, if not both are known at right time, I do the full type checking, I return the expression, and then the simplification phase will take care of that, rather than me having to do 4 or 5 different branches here, and therefore having to do type checking in all of them. Okay, perfect. So, let's try to make this compile. Oh, yes, of course. That's going to require an applicative. Actually, compiler, what is the type of this? Okay. Which is gonna mean that we are gonna need, I think for traverse, it needs to be an applicative, not just a functor? Yeah, applicative. So that means that we have a traversable T1, a traversable T2, and an applicative F, and given a function from A to FB, a T1 of T2 of A, we get an F of T1 of T2 of B. Okay. We have to recompile everything because I touched the prelude. How much GDQ am I missing in the meantime? What's the state of the schedule? Okay. Oh, we're starting the Keizo Mario in 20 minutes. And then Super Metroid. Okay. So that means I should probably stop within 20 minutes if I want to catch the Keizo Mario world. Okay. Int literal, that doesn't exist. That's an int literal expression. Actually, at this point, I could probably literal with literal expression. Expecting one or more argument to definition. Oh, yeah, because of course I have changed my definition of, if I may say so, of simplifiable to no longer take the type argument. So now most of those, if I have instance something where I'm gonna want to replace this by instance 1 to resolved where module no longer takes. Module is not a thing that's resolved. Module is no longer a thing that is. Because module is not. Yes, okay. Module is the past version. There's no version of module for the resolved version. At the moment, the output of this is a resolved module with what is exported and a definition cache. And a definition cache is a bunch of definition resolved. So I guess I can probably take a resolved module there. And rather than doing simplifiable on this, what this is going to do is do I have lenses for this? I don't. I should. Okay. Because now this is a resmod definition cache, traverse to get into the things, traverse to get into the thing. Okay. So now this becomes resmod definition cache dot traverse on which I apply a function which happens to be simplify. Lenses for the win. Except, of course, resolve module is not in scope. I am going to need to be aware. I don't like the idea of a stage being aware of another. That means I'm going to need to move where resolve module is defined at some point. But for now, that means I need this import. That's something I'll probably be able to check at some point. I probably will want to guarantee, probably it's like a maybe a CI check that I don't have any of the stage file importing directly other stages, and they only import things from representation, because each stage is supposed to be independent and therefore using representation that is shared, rather than having a stage simplification import a module of another stage analysis. It's not super important, but I'd like to keep like the import graph clean. And that's one of the ways it would be clean, is each stage only import things from representation or within its own definitions. Make lenses resolve module. What am I missing? Oh, I am missing, of course, template Haskell being in scope. Wait, why do I still need undecidable instances for this? Oh, probably for the pretty. I think HLint would tell me that it's not actually required. No, maybe not HLint, but some things would actually tell me it's not actually required. Okay. Resolve module. I need to also export the lenses that have been created, which is resmod exported and resmod definition cache. One more reason to not define those things in this module. Oh, not resolve exported, resmod exported. Okay. Couldn't match. Oh, because I have already removed. This is deconstructing a const info here and creating a const info here. Fmap simplify const exp. Okay, so what's wrong here? Let's go back here. Let's look at how a const info is defined. This is an annotated expression, and in this case, it means that it is a typed expression. So I'm mapping simplify on the expression within, which requires, okay. Is it because I forgot to make typed expression? Yeah, I guess it's not a functor. It cannot be. It makes no sense for it to be. So, yeah, it doesn't make sense for it to be at all. So that means the fmap is nonsensical. That means I need to simplify it. And I need to make an instance of simplifiable for a typed expression. Where simplify. Have a good evening. Thank you for tuning in. Simplify of a typed expression will be a typed expression again, in which we're gonna simplify the expression type and simplify the expression value. There we go. And now that should be fine. Actually, just quickly answer this message. Okay. What do we have next? Next, we have this function body thing. Is that because... Yes, I think this is probably a simple fmap, because when it is resolved, statements no longer have annotations. So a single fmap is enough now. This is an expression, so it is probably a simple fmap here as well. Let me quickly answer this message as well. Okay. So that's already done. What next? We probably have the same thing where we do a fmap on an if expression that doesn't work. The body is probably going to be a bunch of statements, so it's back to being a simple fmap. Let's see. It's just a simplified directly. And this might be even the same thing here. Oh no, because it's a maybe. So it is an fmap here. Okay. Ah, apparently the Keizo Mario run has started. I don't know why you're still here instead of watching GGQ, but yes, the Keizo Mario run has started. Okay, so the expression no longer requires an fmap. That's probably an fmap here instead of an fmap 2. That's probably going to be the same thing here. Remove 2 layers of fmap. Next, what do we have here? The expression no longer requires an fmap. The type, the type is a maybe, so the fmap is still required. Okay. Ah, we're finally here. So that's a left-hand side expression. Good, we found this before it broke. That's good. This is also my worry about doing all type checking on all of those branches is what if I do the, like, I match the branch of inequality left-hand side something, and I do the type checking on the right-hand side, that would compile and type check. Like, it was very easy to introduce errors that are a lot easier to avoid with that kind of construction. Okay, let's see. Likewise, that's the left-hand side. Oh yeah, of course. Those are not expressions, they are typed expressions, so they contain a type annotation. Thankfully, I have some patterns for this, so I can use int expression instead, so I can remove, so int literal exp becomes int expression everywhere. Boolean literal exp becomes bool expression everywhere, making use of my type aliases, my patterns rather. Except those are not defined as part of, they are defined here. I should probably define them as either as part of the AST or as part of the built-in. I think they make more sense as part of the AST, which is why that's where they're going to go. AST, expressions, and here I'm gonna add those patterns, which means I'm gonna need to take this pattern synonyms and put it here. And I need to check. I'm exporting everything here. I hope in core. Okay, I was not exporting. Okay, so that should be fine. Okay. Int type. This requires knowing about the types, which come from built-ins. That's fine. That's part of the representation. I don't mind the AST being aware of built-ins. That doesn't shock me as being bad as far as dependency arrows go. Oh, it's in batteries. Wait. Built-ins are aware of the AST, not the other way around. Okay. So that means that those things belong in the built-ins, not the other way around. So those are the types, and those are the expressions. Okay. Which means that core needs built-in, it already depends on it, and simplification depends on built-in. That's perfectly fine. That is in batteries built-in. There we go. Okay. And hopefully, I don't think this is gonna compile yet, but we shouldn't be too far. Here I am creating a typed expression. For the return value, this needs to be an actual expression because it will be wrapped in something with the same value, which means this needs to be a bool literal expression. Same thing here. Because my plated instance is on the expression. Okay. Ah, yes. So this needs to be, this is a typed expression of a Boolean type, and I find that within. Except no, this is an int type. The import, of course, is redundant. I agree. I probably don't need to hide mapping and OP there. Oh, of course, and I need to have a match all case where an expression is just... Actually, I don't want transform, I think. Because this does it in a bottom up manner, but there's always the possibility of something being changed, like for instance a equals false becoming a not that requires retraversing the tree because suddenly it creates a not that needs to be removed. So I don't want transform. I want rewrite. Because rewrite will be applied as long as it can. Ensure the rule cannot be applied anywhere in the result. So I want rewrite instead. I want rewrite. And I want all of those arrows to be arrows followed by just this. There we go. Except... up, there we go. And finally, in the general case, I don't need to return the same thing. I return nothing to indicate that in other cases, we have nothing to do. There we go. And with this framework now, we could go a lot further and remove a lot of dead code in statements. For instance, we could... assignments that don't do anything could be replaced by a constant value of type unit, and then statements of type unit could be removed altogether because there are no ops. There's a bunch of things like this we could do with this rewrite. The core idea being that this is a total function. It takes a resolve module, and the resolve module we are post-checking. But anything that we can do that we know is safe should be done here. That's the framework. That's what it's for. Okay, what's missing now? Unused. Yeah, I suppose. Because if I do an false and something, this will short circuit to always be false. Boolean operators are lazily evaluated left to right. They short circuit. Therefore, I don't need to keep the call to the function on the right-hand side or the evaluation of the variable or whatever. I can eliminate it as dead code because it does nothing. Same thing here. When it's true or something, I don't need to evaluate the right-hand side. And now this compiles. Next time, actually, we can start writing tests for the simplification phase, because unlike the analysis phase, that's a phase that's done. We can check that. We can, like, we have the full phase, so we can probably start writing things. Past IST here. And now this compiles. and the tests pass. The very little tests we have, but it's better than nothing, which means before I finish for this evening, I think, because I'm missing the Kaizo run, is there anything else I wanted to do as part of the function analysis? I still haven't fixed the comparison stuff. The comparison stuff is not great. That being said, maybe the comparison stuff is stuff I can do as part of the rewrite? Because the type checking has already been done, so I know that everything is correct. So maybe as part of the rewrite, I can do a much more aggressive rewrite. But I don't want, no. I guess I could try to see if it's possible to do so. The thing I wanted to do here is here in compare expressions. What I do is, okay, can I compare those expressions at compile time? If I cannot, I nope out of this function and I just insert the same comparison. I don't change it. It will be evaluated at runtime. For 2 ints, that's fine. For 2 characters, it's fine. For 2 boolean, it's fine. But if you have literally anything else, a function call and an int, for instance, I cannot compare them at compile time because the function call is not known at compile time, unless it gets inline into constant, but we're not there yet. And in the case of a struct, I only do the comparison if all the fields are known at compile time. But that's not the best thing I could do. Because I could... Actually, does Rust short circuit? Does Rust lazily evaluate fields of a struct for comparison? Only one way to know. Rust Playground. I have a foo here that has 2 ints in it. If I try to do a foo of x 0 and y is error 2 is less than foo of x1 and y is, well, let's say error 1, error 2. Technically, this could be resolved at compile time because struct comparison looks at the fields in declaration order and consider the first one to be the most significant. So this comparison expression can be written: is x, in this case, less than this one? If yes, this thing evaluates to true, and we don't need to compare the other fields. The question is, are the fields computed first before, like, can the lazy evaluation, like, is this expression lazily evaluated? Does it short circuit when it realizes it doesn't have to? And therefore, does this succeed without encountering either this panic or this panic? Nope, it panics. So that means, yeah, again, that's the thing of like, those languages are not lazy. I can't just remove entire computations that might perform side effects just because I can decide what the result of the evaluation would be, because things perform side effects and I can't just remove them. In Haskell, of like, yes, I could absolutely do that kind of optimization because no side effects there. But here I cannot. Even though it's one of those cases where, like, I could compute the value ahead of time, and maybe I'll make use of that for the control flow analysis of like, hey, actually, I can know at compile time that this will always be false or error, or always true or error, and therefore I can mark some branches as like guaranteed to be true or guaranteed to be false, and I can prune dead code as a result. I can probably do that, but I can't remove the code. So the struct thing is probably fine to keep as is. Which means, with all of that said, with all of that done, if I do this, and I then do an as int, and then I do +0 +0 1 times 1 times, and I make that return an int. This should simplify quite a lot, because this should be simplified one less than 2 should be simplified to true. True and something should be simplified to just that thing. Like negation should be simplified to just that. The as int should still be there, but the +0 and 1 times 1 should also be removed. So this should just be 1 is less than x cast as int. Okay. The name of that function is baz. Let's grab that. So baz is a function named baz with no type parameter, with one argument x, which is by value a int, which is a built-in type. It returns just a built-in type, which is an int. And the body is a return statement that contains a typed expression of type int, where the value is a lesser exp, where on the left-hand side we have 1, and on the right-hand side we have a function argument x. The simplification worked. There we go. Whew. Well, that was progress. We did a lot of function expressions. Still not as much as I would like. No short-circuiting on the struct evaluation, which is kind of annoying. I would really like to be able to do better, but again, I'm not sure from a semantic perspective I'm allowed to remove things that can perform side effects, so I probably won't be able to do that. But we have now a new phase, the simplification phase, which is mostly about not touching two things too much, but with the basically all of this is boilerplate for this function, basically, that does all of those replacements, but it does them after type checking, so now this is safe. And we could go a lot further. There's a lot of dead code we can find with this. Well, for instance, a lot of things where like assignment things are useless, we can probably return the same thing instead. Like there's a lot of things we can do. One thing I want to check actually in Rust, if I have let x I64 equals 0, and let's make it mutable. What is a type of x plus equal 1? Does this return the value of x, or is it not a, like, or is it unit, basically? It is unit. Okay. Assignments cannot be chained. This doesn't return a value. There's no... Okay. So that means I could potentially do the same, where I could replace an x plus equals 0, or minus equals 0, or times equal 1, or something like this. When I've done those, which I haven't done yet, they will be of type unit anyway. And I could replace them with like a constant unit, basically, which I don't have in my expression syntax yet, but would not be absurd to have. But that's gonna be something for next time. Because I've been streaming for 5 hours and a half. It might be time to take a break and go watch some GGQ. So, now that this compiles, yeah, I've modified basically everything. Let's quickly have a look at grep. Where do I use fmap2 in the end? I do use it. Okay, I'm gonna keep the traverse to an fmap2. They might prove useful. Oh, interesting. The image library I use for my image generations has a traverse too. Fun. Okay, so let's commit all of this nonsense. First, then is there anything else I can do that's not too monstrous? I guess moving the pattern synonyms from core to built-in is not a big change. It doesn't require changing anything else. Okay. Next, next, excuse me. Okay. And finally, this is where we add the simplification phase. We add the change to the export. We add the change to the top level module to actually make use of it, where now we simplify module on the resolve AST. So we are doing this phase, and yeah, there we go. Add new simplification phase. Push to GitHub, and I'm gonna stop here. Thank you everyone for tuning in. That was a good one. A lot of progress this evening. And yeah, I think Tuesday I will. I really need to finish the analysis. I am so close to finishing the analysis and being finally able to write some tests for it. So I think that's what I really need to prioritize. I need to prioritize finishing the analysis. And then when that's done, I can finally spend like a few weeks just writing tests for all of this so I can get rid of my absolutely horrible test file and have reliable tests instead. Okay, that's a problem for next time. Thank you again for tuning in. As a reminder, I'm part of the Declarative TV group of people who stream in. Oh, the prompt has been up. There we go. People who stream in functional and declarative languages. We have a Discord. If you want to hang out and talk about the project on Discord, that's where to find me. Anyway, see you all next time.